Let's delve into the intriguing question. Do we need God to explain how the universe started from nothing? This topic has captivated the minds of philosophers, scientists, theologians, and laypeople for centuries. It sits at the intersection of deep existential inquiry and the cutting edge of scientific discovery. The origins of the universe touch on fundamental aspects of human curiosity. What was the universe like before the Big Bang, if such a state even existed? Is there a higher power behind the creation of everything we see and experience? These are questions that drive our quest for knowledge. This discussion is not just academic. It has profound implications for how we see ourselves and our place in the cosmos. Whether you approach it from a religious, scientific, or philosophical perspective, the way we answer this question shapes our worldview. Exploring this topic requires an understanding of several complex concepts. From the scientific side, we need to grasp theories like the Big Bang and quantum mechanics. On the philosophical and theological fronts, we must consider arguments for and against the existence of God as the prime mover. In religious traditions, the concept of God creating the universe from nothing is a central tenet. This belief is found in many creation myths and sacred texts. It provides a framework for understanding the origins of existence in a way that is deeply meaningful for billions of people. On the other hand, scientific explanations often do not require a divine being. The Big Bang theory, for instance, describes a universe that began as an incredibly hot and dense point approximately 13.8 billion years ago. This theory is supported by a wealth of observational evidence. Yet the Big Bang theory also raises further questions. What caused the Big Bang? What existed before it? These are mysteries that continue to challenge scientists. Some propose that our universe is just one of many in a vast multiverse, each with its own origins. Arguments like the cosmological argument suggest that everything that begins to exist has a cause, and this cause must be God. Critics, however, argue that this is not necessarily the case. The interplay between science and religion in this debate is fascinating. While some see them as fundamentally opposed, others find ways to harmonize scientific findings with their faith. This dialogue continues to evolve, influencing both scientific inquiry and theological thought. Prominent figures on both sides have contributed significantly to this discussion. Scientists like Stephen Hawking have argued for a universe that can create itself from nothing, relying on the laws of physics. Meanwhile, theologians like William Lane Craig defend the necessity of a divine creator. Public interest in this topic remains high. It frequently appears in books, films, and public debates, reflecting its enduring relevance. People from all walks of life engage with these ideas, seeking answers to one of humanity's oldest questions. Personal beliefs and experiences also play a crucial role. Individual upbringing, education, and cultural background can shape how one views the necessity of God in explaining the universe. This personal dimension adds another layer of complexity to the discussion. In considering alternative explanations, we encounter a wide array of theories. Some scientists and philosophers propose that the universe might be a simulation, or that consciousness itself is a fundamental aspect of reality. These ideas push the boundaries of conventional thinking. The topic also prompts us to consider the limits of human knowledge. There are aspects of the universe that we may never fully understand. This humility can be a unifying factor, encouraging dialogue and exploration across different perspectives. Engaging with this question invites us to expand our minds and challenge our assumptions. Whether through scientific research, philosophical reflection, or theological study, we are all part of this grand quest to understand our origins. By examining this question from multiple angles, we gain a deeper appreciation for the complexity of the universe. It's a journey that not only seeks answers, but also enriches our understanding of existence itself. The importance of the question about whether we need God to explain the universe's origin cannot be overstated. This inquiry goes to the heart of our understanding of existence and our place in the cosmos. It's a question that resonates with the deepest parts of our human experience. This question is fundamental to various fields of study, from cosmology to theology. It bridges the gap between science and religion, encouraging dialogue and exploration. By grappling with this question, we challenge ourselves to think beyond the immediate and the tangible. In the realm of science, the origins of the universe are a key focus. Scientists seek to uncover the mechanisms that led to the formation of everything we know. This pursuit has led to incredible discoveries and continues to push the boundaries of our knowledge. Religiously, the question touches on the core of many faith traditions. The belief in a divine creator shapes how billions of people see the world and their place in it. It provides a foundation for understanding life, purpose, and the nature of existence. Philosophically, the question invites deep reflection. It asks us to consider the nature of causality, existence, and the possibility of something coming from nothing. Philosophers have debated these concepts for millennia, each offering unique insights and arguments. This question also has significant implications for how we view ourselves. If the universe has a divine origin, it suggests a purpose and intentionality behind our existence. If it does not, we must grapple with the idea of a universe that exists without inherent meaning. Culturally, the question influences art, literature, and media. It inspires countless works that explore themes of creation, existence, and the divine. These cultural expressions reflect our ongoing fascination with the origins of the universe and our quest for understanding. Politically, the question can impact policy and education. Debates about teaching creationism versus evolution in schools, for instance, highlight the intersection of this question with public life. The way we address it can shape educational standards and societal values. The question also resonates on a personal level. For many, it is tied to their sense of identity and belonging. Beliefs about the universe's origins can influence how people live their lives, their ethical frameworks, and their interactions with others. In terms of existential inquiry, this question prompts us to look inward. It challenges us to confront our own beliefs and assumptions about the nature of reality. This introspection can lead to profound personal growth and a deeper understanding of ourselves. Technologically, advancements in our ability to observe and understand the universe directly relate to this question. Telescopes, particle accelerators, and other scientific tools provide new insights, continually reshaping our understanding of the cosmos. Educationally, this question is a powerful tool for engaging students. It encourages critical thinking, debate, and exploration. By examining the origins of the universe, students learn to question, analyze, and seek evidence, skills that are valuable in all areas of life. Historically, how we have answered this question has evolved. From ancient creation myths to modern scientific theories, our answers reflect the knowledge and cultural context of their times. Studying this history helps us appreciate the journey of human understanding. Psychologically, the question can influence our mental well-being. Beliefs about the universe's origins can provide comfort or challenge us to find meaning in a seemingly indifferent cosmos. This aspect highlights the interplay between knowledge and human experience. Ultimately, the importance of this question lies in its ability to inspire curiosity and wonder. Whether through scientific discovery, philosophical reflection, or spiritual exploration, it drives us to seek a deeper understanding of the universe and our place within it. The debate over whether God is needed to explain the universe's origin dates back to ancient times. Philosophers in ancient Greece, like Plato and Aristotle, pondered the nature of existence and the cosmos. They questioned whether a prime mover or an uncaused cause was necessary to set everything into motion. In medieval times, theologians like Thomas Aquinas built on these ideas. Aquinas developed the cosmological argument, positing that everything that exists must have a cause, ultimately leading to a first cause, which he identified as God. This became a cornerstone of Christian theology. During the Enlightenment, the debate took on new dimensions as scientific discoveries began to challenge traditional religious views. Figures like Isaac Newton and later Pierre-Simon Laplace explored natural laws that could explain the workings of the universe without invoking divine intervention. In the 19th century, Charles Darwin's theory of evolution further fueled the debate. The idea that natural selection could account for the complexity of life challenged the notion that a creator was necessary for life's diversity. This sparked intense discussions between science and religion. The 20th century saw the advent of the Big Bang theory, which proposed that the universe had a definite beginning. This scientific model resonated with the concept of a creation event, but it also raised questions about what, if anything, preceded the Big Bang. Scientists like Georges Lemaitre, who was also a priest, found ways to reconcile these ideas with their faith. At the same time, atheists like Bertrand Russell argued that the universe could be self-existent and didn't require an explanation beyond natural causes. This perspective gained traction as science provided more detailed accounts of the universe's development. In the mid-20th century, physicists began to explore quantum mechanics and the possibility that the universe could arise from quantum fluctuations. Richard Feynman and others suggested that the laws of physics might allow for the spontaneous creation of universes, further complicating the debate. The late 20th and early 21st centuries have seen prominent scientists and thinkers like Stephen Hawking and Lawrence Krauss argue that a universe can indeed come from nothing, given the laws of physics. They proposed models where the universe's existence is a natural outcome of physical laws. On the other hand, philosophers and theologians such as Alvin Plantinga and William Lane Craig continue to argue for the necessity of a divine creator. They critique the idea that natural laws alone can account for the universe's existence, emphasizing the need for an ultimate cause. The dialogue between science and religion remains vibrant. Institutions and conferences dedicated to exploring these questions have proliferated, bringing together experts from various fields to discuss and debate. Public interest in this debate has grown, with books, debates, and documentaries reaching wide audiences. Figures like Richard Dawkins have popularized atheistic viewpoints, while others like Francis Collins have shared their perspectives as scientists who believe in God. The Internet has further democratized the debate, allowing for a global exchange of ideas. Online forums, social media, and educational platforms have become arenas where these questions are continuously explored and challenged. Educational systems worldwide grapple with how to present these ideas. The debate influences curricula, with discussions on whether to teach creationism, intelligent design, or strictly scientific explanations of the universe's origin. Throughout history, art and literature have also reflected this debate. Works from Dante's Divine Comedy to modern science fiction explore themes of creation, existence, and the divine, showing the enduring nature of these questions. Today, the debate is as dynamic as ever. As our understanding of the universe evolves, so too do the arguments and perspectives on whether a divine being is needed to explain it. This ongoing conversation continues to shape our collective understanding of existence. Defining nothingness is a complex and nuanced task that has puzzled thinkers for centuries. In everyday language, nothingness typically means the absence of anything. But in the context of the universe's origins, it takes on a much deeper meaning. From a philosophical perspective, nothingness can be seen as the complete absence of being. It's a state where no matter energy, space, or time exists. This concept challenges our understanding because it contradicts our experience of a universe filled with something. Scientifically, nothingness is approached differently. Physicists often describe it as a vacuum state, which, even in its emptiest form, can still have fluctuations in quantum activity. This idea suggests that what we perceive as nothing might not be truly empty. In quantum mechanics, nothingness isn't absolute. The quantum vacuum is a seething background of temporary particle pairs popping in and out of existence. This challenges the classical idea of a void and introduces a dynamic component to nothingness. The concept of nothingness also varies across different cultures and philosophies. In some Eastern traditions, nothingness is seen as a form of potential, a fertile ground from which creation can emerge. This contrasts with the Western notion of nothing as a void. Religious interpretations of nothingness often involve a state before creation, where only the divine exists. In these views, God brings forth the universe from this nothingness, imbuing it with order and purpose. Historically, the idea of nothingness has been debated by many great thinkers. Ancient Greek philosophers like Parmenides argued that nothingness cannot exist because thinking about nothing implies it is something. This paradox highlights the difficulty of grasping this concept. In modern times, philosophers like Martin Heidegger have explored nothingness as a fundamental aspect of human existence. Heidegger suggested that confronting nothingness leads to a deeper understanding of being and the nature of reality. Physicists like Lawrence Krauss have popularized the idea that the universe could come from nothing, relying on the principles of quantum mechanics. This scientific viewpoint redefines nothingness in terms of physical laws and probabilities. The concept of nothingness also plays a role in cosmology. Theories about the universe's origin, including the Big Bang, often start with a state that is devoid of the traditional markers of existence. This initial state of nothingness is key to understanding how the universe could begin. In mathematics, nothingness can be related to the concept of zero or the empty set. These abstract notions help us grapple with the idea of absence and provide a framework for thinking about nothing in a structured way. Nothingness is also a topic in existential philosophy. Thinkers like Jean-Paul Sartre have explored the relationship between nothingness and human freedom, suggesting that recognizing nothingness allows for the creation of meaning and purpose in an otherwise indifferent universe. In literature and art, nothingness often symbolizes emptiness, void, or the potential for creation. Artists and writers use this concept to evoke feelings of mystery, fear, and wonder, reflecting our complex relationship with the idea of nothing. The debate over the nature of nothingness continues to evolve. As new scientific discoveries are made, our understanding of what nothing means may change, offering fresh insights into this age-old question. Ultimately, nothingness is a profound and multifaceted concept that touches on the deepest aspects of philosophy, science, and human experience. It challenges us to think beyond the tangible and question the very nature of existence itself. Philosophical perspectives on nothingness offer a rich tapestry of thought that spans centuries. Ancient Greek philosophers like Parmenides and Democritus grappled with the idea of nothingness. Parmenides argued that nothingness cannot exist because thinking about nothing involves thinking about something, creating a paradox. Contrastingly, Democritus introduced the concept of the void, a type of nothingness necessary for the existence of atoms and movement. This idea laid the groundwork for later philosophical and scientific explorations of empty space and the nature of the universe. Medieval philosophers, particularly within the Christian tradition, viewed nothingness in theological terms. Thomas Aquinas, for example, discussed creation ex nihilo, or creation from nothing, as an act of divine will, emphasizing God's power to create without pre-existing material. In the Enlightenment, philosophers like John Locke and David Hume took a more empirical approach. They questioned the very concept of nothingness, focusing instead on what can be known and experienced. Locke's tabula rasa, or blank slate, metaphorically connected to nothingness as the mind's starting point. German idealist philosophers, such as Immanuel Kant, explored nothingness in the context of metaphysics. Kant argued that nothingness is a concept we use to describe the limits of our knowledge, emphasizing the boundaries of human understanding. In the 19th century, existentialist philosophers like Friedrich Nietzsche and Søren Kierkegaard brought a new dimension to the concept. Nietzsche's idea of the eternal recurrence and Kierkegaard's exploration of the leap of faith delve into the existential implications of nothingness and meaning. Martin Heidegger, a prominent 20th century philosopher, deeply examined nothingness in his work Being and Time. Heidegger saw nothingness as essential to understanding being, proposing that confronting nothingness leads to a more profound grasp of existence. Jean-Paul Sartre further developed existentialist ideas, famously stating, "Existence precedes essence." For Sartre, nothingness is intrinsic to human freedom, allowing individuals to define their own essence through choices, despite the absence of inherent meaning. In contrast, analytic philosophers like Ludwig Wittgenstein approached nothingness through language and logic. Wittgenstein suggested that many philosophical problems, including those about nothingness, arise from misunderstandings of language. Eastern philosophies, such as those in Buddhism and Taoism, offer unique perspectives on nothingness. Buddhism's concept of sunyata, or emptiness, denotes the absence of inherent existence in all things, emphasizing interdependence and the potential for enlightenment. Taoism speaks of the Tao as a fundamental principle that precedes existence and non-existence. Laozi's writings suggest that embracing nothingness, or wu-wei, leads to harmony with the natural order of the universe. Contemporary philosophers continue to explore nothingness in various contexts. Some, like Alain Badiou, examine it in terms of set theory and mathematical structures, while others, like Quentin Meillassoux, discuss it within speculative realism, questioning the necessity of a principle of sufficient reason. The intersection of philosophy and science also yields intriguing discussions about nothingness. Philosophers of science such as Karl Popper and Thomas Kuhn explore how scientific paradigms address or avoid the concept of nothingness. Ultimately, philosophical perspectives on nothingness challenge us to think deeply about existence, reality, and our place in the universe. These diverse views offer a rich field of inquiry that continues to inspire and provoke thought across disciplines. The question of nothingness is more than an abstract puzzle. It touches on fundamental issues of life, knowledge, and the cosmos. By engaging with these philosophical perspectives, we gain a deeper understanding of one of humanity's most profound questions. Scientific perspectives on nothingness offer a fascinating look into the nature of the universe. In the realm of cosmology, the Big Bang theory provides a foundational explanation. It posits that the universe began from an extremely hot and dense singularity around 13.8 billion years ago, expanding into the cosmos we observe today. Quantum mechanics introduces another layer to our understanding of nothingness. According to quantum field theory, what we consider empty space is not truly empty. Instead, it is filled with fluctuating fields and virtual particles that pop in and out of existence. The concept of a vacuum in quantum physics challenges traditional notions of nothingness. Even in a perfect vacuum, particles and antiparticles can spontaneously appear and annihilate each other, creating a dynamic rather than a static emptiness. The idea of vacuum energy is central to this discussion. This energy inherent in empty space can have profound effects on the universe's structure and behavior, influencing everything from the expansion of the universe to the behavior of particles at the smallest scales. Physicists like Lawrence Krauss have argued that these quantum fluctuations can explain how something can come from nothing. In his view, the laws of physics, particularly quantum mechanics, make the spontaneous creation of the universe not just possible but inevitable. Cosmologists also explore the concept of a multiverse. This theory suggests that our universe might be one of many, each with different physical laws and constants. In some models, these universes can spontaneously bud off from a parent universe, raising questions about the nature of nothingness between them. The study of dark energy and dark matter further complicates our understanding of nothingness. Dark energy, which drives the accelerated expansion of the universe, and dark matter, which affects its gravitational structure, hint at unseen and unknown aspects of the cosmos that challenge our comprehension of empty space. In the context of general relativity, the fabric of space-time itself can be warped and curved by mass and energy. This interplay suggests that even the structure of space, what we might consider the backdrop of nothingness, is dynamic and interactive. Stephen Hawking's work on black holes and the origin of the universe adds another dimension. Hawking radiation implies that black holes can emit particles, blurring the line between something and nothing. His no-boundary proposal also suggests that the universe could be finite but without boundaries, complicating the concept of a beginning. Theoretical physics also introduces the idea of a false vacuum. This is a metastable state that might appear stable but could transition to a lower energy state, potentially explaining how our universe could arise from a pre-existing condition of nothingness. The anthropic principle provides a philosophical context to scientific perspectives. It suggests that the universe's properties must allow for the existence of observers, like humans, which in turn influences our understanding of why the universe appears the way it does. This principle intersects with scientific theories about the origins of the universe. Experiments like those conducted with the Large Hadron Collider aim to explore these ideas further. By recreating conditions similar to those just after the Big Bang, scientists hope to understand the fundamental forces and particles that define our universe. Scientific perspectives on nothingness continually evolve as new discoveries are made. The interplay between theory and observation drives our understanding forward, often leading to more profound questions and insights about the universe's true nature. Interdisciplinary approaches combining physics, cosmology, and philosophy offer the most comprehensive understanding. These perspectives collectively push the boundaries of what we know about existence, challenging our perceptions of reality and nothingness. Ultimately, scientific perspectives on nothingness reveal a universe far more complex and dynamic than traditional notions of emptiness. These insights invite us to reconsider our place in the cosmos and the fundamental nature of reality itself. Understanding the historical context of nothingness helps us see how this concept has evolved over time. In ancient Greece, philosophers like Parmenides argued that nothingness could not exist, as thinking about nothing implies thinking about something, creating a paradox. Democritus introduced the idea of the void, suggesting that empty space is necessary for atoms to move. This early concept of nothingness laid the groundwork for later scientific and philosophical explorations of space and matter. During the Middle Ages, theological perspectives dominated the discussion. Christian theologians like Augustine and Thomas Aquinas discussed creation ex nihilo, or creation from nothing, emphasizing God's power to bring the universe into existence without pre-existing material. The Renaissance and Enlightenment periods brought significant shifts. As scientific inquiry gained prominence, thinkers like René Descartes and Isaac Newton explored the nature of space and the possibility of a vacuum. Their work challenged traditional views and set the stage for modern physics. In the 17th century, the concept of a vacuum was experimentally investigated by scientists like Blaise Pascal and Otto von Guericke. Guericke's experiments with the Magdeburg hemispheres demonstrated the power of atmospheric pressure and the reality of a vacuum, advancing our understanding of empty space. The development of Newtonian physics further influenced the concept of nothingness. Newton's laws of motion and universal gravitation described a universe governed by predictable laws, where space could be considered a vast, empty expanse in which objects move. The 19th century saw the rise of thermodynamics and electromagnetism. Scientists like James Clerk Maxwell and Ludwig Boltzmann explored the properties of energy and entropy, contributing to the understanding that even empty space has measurable properties. Einstein's theory of general relativity, introduced in the early 20th century, revolutionized our understanding of space and time. According to Einstein, space and time are interconnected and can be warped by mass and energy, challenging the notion of an absolute empty space. The discovery of quantum mechanics in the 20th century added another layer to the concept of nothingness. Quantum field theory revealed that what appears to be empty space is actually filled with fluctuating fields and particles, constantly appearing and disappearing. Cosmological discoveries, such as the Big Bang theory, further shaped the historical context of nothingness. The idea that the universe began from an incredibly hot and dense state, expanded into the current cosmos, challenged traditional notions of an eternal, unchanging universe. The exploration of dark matter and dark energy in recent decades has complicated our understanding of nothingness. These mysterious components of the universe suggest that much of what we thought was empty space is actually filled with unknown forms of matter and energy. Philosophically, the 20th century saw existentialist thinkers like Jean-Paul Sartre and Martin Heidegger exploring nothingness in terms of human existence and meaning. Their work emphasized the role of nothingness in shaping human freedom and understanding of being. Contemporary physicists continue to investigate the nature of nothingness. Experiments at facilities like the Large Hadron Collider aim to recreate conditions similar to those of the early universe, probing the fundamental forces and particles that define our reality. Historical context shows us that the concept of nothingness has evolved alongside human knowledge. From ancient philosophical debates to modern scientific discoveries, our understanding of nothingness reflects the broader quest to comprehend the nature of the universe. By examining the historical context, we gain insight into how different cultures and eras have grappled with the idea of nothingness, shaping the ongoing dialogue between science, philosophy, and theology. One common misconception is that nothingness is a simple, absolute void. In reality, even what we consider empty space is teeming with quantum activity, where particles constantly appear and disappear. Another misconception is that the Big Bang theory explains the origin of the universe from absolute nothingness. The theory actually describes the expansion of the universe from an extremely hot and dense state, but it doesn't specify what came before that or why it happened. Many people believe that science and religion are inherently opposed when it comes to explaining the universe's origins. In fact, numerous scientists hold religious beliefs and see no conflict between their faith and their scientific work. There's a misunderstanding that the concept of nothingness has a universally accepted definition. In truth, it varies significantly between disciplines like physics, philosophy, and theology, each offering different perspectives on what nothingness entails. Some think that the idea of a vacuum means total emptiness. However, In physics, a vacuum is not devoid of energy or activity. Quantum fields permeate space, leading to phenomena like virtual particles and vacuum energy. A widespread misconception is that the universe is static and unchanging. Observations show that the universe is expanding, and this dynamic nature affects our understanding of nothingness and the cosmos. Many assume that before the Big Bang, there was nothing at all. This assumption overlooks various scientific hypotheses about pre-Big Bang conditions, such as cyclical models or the concept of a multiverse. It's commonly thought that nothingness implies a lack of laws or order. Yet, quantum mechanics shows that even in the most seemingly empty spaces, physical laws govern the behavior of particles and energy. People often confuse the philosophical concept of nothingness with the scientific one. Philosophically, nothingness can involve existential and metaphysical dimensions, while scientifically, it often refers to conditions in space and quantum fields. Another misconception is that the universe's origin can be fully explained by a single theory or perspective. The reality is that multiple theories and models from different fields contribute to our understanding of how the universe might have arisen from nothing. Some believe that discussing nothingness is purely speculative with no practical implications. In contrast, these discussions have profound implications for fields like cosmology, quantum physics, and even technology development. There's a belief that nothingness negates the need for further inquiry. In fact, exploring the concept of nothingness pushes the boundaries of scientific and philosophical research, leading to new discoveries and deeper understanding. Many think that the concept of nothingness is a modern idea. However, historical records show that ancient civilizations and philosophers have long pondered the nature of nothingness and its implications for existence. Another misconception is that scientific models of the universe's origin completely exclude the possibility of a creator. Some scientists and theologians find ways to reconcile scientific explanations with the idea of a divine creator. Lastly, people often think that we currently have all the answers about the universe's origins. The truth is that this is an ongoing field of study, with new discoveries continually reshaping our understanding of nothingness and the cosmos. Creation myths from around the world offer diverse explanations for the origins of the universe. These stories reflect the cultural and spiritual beliefs of different societies throughout history. In ancient Mesopotamia, the Enuma Elish describes the creation of the world from a chaotic, watery abyss. The gods Marduk and Tiamat play central roles in shaping the cosmos and establishing order. The ancient Egyptians believed in the primeval waters of Nun, from which the sun god Ra emerged. Ra then created other gods in the world, bringing light and life to the universe. Greek mythology presents a cosmogony, where chaos, a primordial void, gives rise to Gaia, the earth, and other deities. These gods and titans then shape the world through their interactions and conflicts. In Hindu cosmology, the Rig Veda describes the universe emerging from a cosmic egg, or Hiranyagarbha. This egg contained the essence of all things, which expanded to form the cosmos. The Norse creation myth tells of a primordial void called Ginnungagap, flanked by realms of fire and ice. The collision of these realms gave rise to Ymir, a giant whose body was used to create the world. Indigenous Australian Dreamtime stories describe the world as being sung into existence by ancestral spirits. These stories emphasize the interconnectedness of all life and the land. In Chinese mythology, the Pangu myth recounts the creation of the world from a cosmic egg. Pangu emerged from the egg and separated the sky and earth, shaping the physical world through his actions. The Judeo-Christian creation narrative in Genesis describes God creating the world in 6 days. God brings order out of chaos, culminating in the creation of humans in his image. The Zoroastrian creation story involves Ahura Mazda, the supreme god, who creates the world in a series of steps. This story emphasizes the duality of good and evil forces in the cosmos. In Mayan mythology, the Popol Vuh recounts the creation of the world by the gods from a primordial sea. The gods attempt to create humans several times, ultimately succeeding with beings made from maize. African creation myths vary widely across the continent. For example, the Yoruba story tells of the god Obatala creating humans from clay, while other gods breathe life into them. The Inca believed in the god Viracocha, who emerged from the waters of Lake Titicaca to create the world and humanity. He brought order to the chaos and established the natural order. Polynesian myths often describe the world emerging from a vast ocean. In Maori tradition, the separation of the Sky Father Ranginui and the Earth Mother Papatuanuku allows light to enter the world. Japanese Shinto mythology includes the story of Izanagi and Izanami, deities who create the islands of Japan. Their offspring and actions shape the natural world and its features. These creation myths, while varied, share common themes of order emerging from chaos, the interplay of divine forces, and the significance of the natural world. They provide insight into how different cultures understand the origins of the universe and humanity's place within it. Theistic arguments for the existence of God often center on the idea that the universe requires a creator. One of the most well-known theistic arguments is the cosmological argument. It posits that everything that begins to exist has a cause, and since the universe began to exist, it must have a cause, which is identified as God. Another key argument is the teleological argument, or the argument from design. This argument suggests that the complexity and order of the universe indicate a purposeful design, which implies the existence of an intelligent designer, God. The moral argument is another significant theistic argument. It claims that objective moral values and duties exist, and since these cannot be grounded in a materialistic worldview, they must be anchored in a transcendent source, which is God. The ontological argument, first proposed by Anselm of Canterbury, is a more abstract argument. It posits that God, being defined as the greatest conceivable being, must exist in reality because existence in reality is greater than existence in the mind alone. The argument from contingency is another important theistic argument. It states that everything in the universe is contingent, meaning it relies on something else for its existence. Therefore, there must be a necessary being that causes everything else, and this necessary being is God. Aquinas' 5 ways are classic theistic arguments. They include the argument from motion, the argument from causation, the argument from contingency, the argument from degrees of perfection, and the teleological argument. Each of these attempts to demonstrate the necessity of God as the first cause or ultimate explanation. The Kalam cosmological argument, popularized by contemporary philosopher William Lane Craig, focuses on the beginning of the universe. It argues that since the universe began to exist, it must have a cause outside of itself, which is God. The fine-tuning argument observes that the conditions necessary for life in the universe are so precise that they are unlikely to have occurred by chance. This fine-tuning suggests the presence of a deliberate tuner, which is God. The argument from reason posits that human rationality and the ability to understand the universe are best explained by the existence of a rational creator. It argues that naturalistic explanations fail to account for the reliability of human cognition. The moral argument can also be extended to argue that the existence of evil and suffering, paradoxically, points to the existence of God. This argument suggests that recognizing evil presupposes an objective moral standard, which implies a moral lawgiver, God. The argument from religious experience claims that personal experiences of the divine, which are widespread and varied across cultures, provide evidence for the existence of God. These experiences are often transformative and deeply meaningful. The argument from consciousness posits that the existence of subjective experience and self-awareness cannot be fully explained by physical processes alone. This suggests the existence of a non-material source of consciousness, which is God. The aesthetic argument asserts that the existence of beauty in the world points to a creator. This argument suggests that the appreciation of beauty and the existence of beautiful things are best explained by the presence of a divine artist, God. The argument from miracles contends that certain events which appear to be violations of natural laws are best explained by the intervention of a supernatural being. Miracles, therefore, serve as evidence for the existence of God. Lastly, the existential argument explores the human need for meaning, purpose, and hope. It suggests that these deep-seated human desires point to the existence of God, who provides the ultimate fulfillment of these needs. Scriptural references to the creation of the universe provide foundational perspectives in many religious traditions. In the Bible, the book of Genesis opens with, "In the beginning, God created the heavens and the earth. This passage establishes God's role as the creator of all things. The Quran also speaks of creation, stating, "It is Allah who created the heavens and the earth and whatever is between them in 6 days. Then he established himself above the throne." This underscores the Islamic view of a purposeful creation by a singular divine being. In Hinduism, the Rig Veda describes the creation of the universe from a cosmic egg, emphasizing the role of a primordial being or principle in bringing forth existence. The Nasadiya Sukta, or Hymn of Creation, explores the mystery and wonder of the universe's origins. Buddhist scriptures often focus less on creation and more on the cyclical nature of existence. However, they do address the beginningless nature of the cosmos and the importance of understanding the interdependent origination of all phenomena. In Jewish texts, the Talmud elaborates on the Genesis creation story, providing interpretations and insights into the nature of God's creative act and the order of creation. These writings offer a detailed exegesis of the biblical narrative. The Book of Mormon, a sacred text in the Latter-day Saint tradition, affirms the biblical account of creation while adding additional insights. It emphasizes the role of Jesus Christ as the creator under the direction of God the Father. Sikh scriptures, such as the Guru Granth Sahib, describe the creation of the universe by a single, formless God. The text emphasizes the creative power of God's word, or Shabad, which brought the cosmos into being. In the Zoroastrian tradition, the Avesta contains references to Ahura Mazda, the supreme God, who created the world in a series of stages. These scriptures highlight the struggle between order and chaos in the universe. The Tao Te Ching, a foundational text in Taoism, speaks of the Tao as the source of all creation. It describes the Tao as the unnameable and eternal principle that gives rise to the heavens and the earth. Indigenous religions often have rich oral traditions that convey their creation stories. These narratives typically emphasize the interconnectedness of all life and the spiritual forces that shape the natural world. In Jainism, the concept of Lokakasha describes the universe's structure, emphasizing its eternal and uncreated nature. Jain scriptures focus on the eternal cycles of creation and destruction, rather than a single act of creation. The Baha'i faith's writings affirm the divine creation of the universe. Baha'u'llah, the founder, speaks of God's creative word bringing all things into existence, emphasizing the unity and purpose inherent in creation. Ancient Egyptian texts, such as the pyramid texts and the coffin texts, contain creation myths involving gods like Atum, who emerged from the primordial waters of Nun to create the world. These texts highlight the divine order imposed on chaos. In Greek mythology, Hesiod's Theogony recounts the origins of the gods and the cosmos. It describes the emergence of the world from chaos, followed by the births of Gaia, Tartarus, and Eros, setting the stage for the creation of the world as known to the Greeks. The Norse poetic Edda includes the Völuspá, which describes the creation of the world from the body of the giant Ymir, slain by Odin and his brothers. This myth emphasizes the cyclical nature of Norse cosmology, with creation arising from destruction. These scriptural references across various traditions provide diverse and profound insights into how different cultures and religions understand the origins of the universe and the role of the divine in creation. Modern theologians continue to explore and expand upon traditional views of creation and the universe's origins. They integrate contemporary scientific discoveries with age-old theological insights, providing fresh perspectives on age-old questions. Alvin Plantinga is a prominent philosopher and theologian known for his work on the rationality of belief in God. He argues that belief in God can be a properly basic belief, not necessarily requiring empirical evidence, and has also addressed the compatibility of science and religion. John Polkinghorne, a physicist turned Anglican priest, bridges the gap between science and theology. He has written extensively on how scientific understanding of the universe can coexist with belief in a divine creator, emphasizing the complementary nature of these perspectives. William Lane Craig is well known for his defense of the Callum cosmological argument. He argues that the universe's beginning necessitates a cause which he identifies as God, combining philosophical reasoning with scientific evidence to support his case. N.T. Wright, a biblical scholar, focuses on the historical and theological context of the Christian faith. He explores how the resurrection of Jesus and the concept of new creation provide a framework for understanding God's ongoing relationship with the cosmos. Jürgen Moltmann, a German Reformed theologian, is noted for his works on hope and eschatology. He presents a theology that emphasizes God's creative and redemptive work in the world, suggesting that creation is an ongoing process leading towards ultimate fulfillment. Elizabeth Johnson, a Catholic theologian, explores feminist theology and the concept of God in relation to creation. She emphasizes the interconnectedness of all life and the importance of ecological responsibility, viewing creation as a manifestation of God's love. Keith Ward, a British philosopher and theologian, writes on the relationship between science and religion. He argues for a theistic interpretation of the universe, suggesting that scientific discoveries about the cosmos point towards a purposeful creator. David Bentley Hart, an Eastern Orthodox theologian, critiques both atheism and certain forms of theism. He advocates for a more mystical and metaphysical understanding of God and creation, arguing that the universe's beauty and complexity reflect the divine. Paul Davies, a physicist with interest in theology, explores the implications of modern science for understanding the divine. He suggests that the laws of physics and the fine-tuning of the universe point towards a deeper, possibly divine reality. Hans Kung, a Swiss Catholic priest and theologian, has written extensively on the compatibility of faith and reason. He addresses how modern scientific insights can enrich theological understanding and how belief in God remains relevant in the contemporary world. Sarah Coakley, an Anglican theologian, integrates systematic theology with insights from philosophy and science. She explores how the concept of the Trinity can inform our understanding of creation, emphasizing relationality and divine action in the world. Ian Barber, a pioneer in the dialogue between science and religion, proposed models for understanding their interaction. He emphasized that science and religion address different questions but can inform each other, particularly in understanding the origins of the universe. Arthur Peacock, a biochemist and priest, developed a theological perspective that embraces evolutionary theory. He argued that God's creative action can be understood through the processes of evolution, viewing science as a means to appreciate the divine. Alistair McGrath, a theologian with a background in molecular biophysics, writes on the relationship between science and religion. He argues against the conflict model and for a harmonious view where scientific discoveries enhance theological reflection. Richard Swinburne, a philosopher of religion, has contributed significantly to the philosophy of theism. He presents arguments for the existence of God based on the complexity and order of the universe, suggesting that theism offers the best explanation for these features. These modern theologians show that the dialogue between science and theology is vibrant and ongoing. They offer diverse perspectives that help bridge the gap between understanding the universe through scientific inquiry and interpreting it through a theological lens. Criticisms of religious explanations for the universe's origins come from various quarters, including scientific, philosophical, and atheistic perspectives. These criticisms often challenge the necessity, coherence, and empirical basis of invoking a divine creator. One major criticism is the lack of empirical evidence for the existence of God. Critics argue that religious explanations rely on faith rather than observable and testable phenomena, which places them outside the scope of scientific inquiry. Another criticism focuses on the problem of evil. If an all-powerful, all-knowing, and benevolent God created the universe, why does evil and suffering exist? This question challenges the coherence of a divine creator being both omnipotent and perfectly good. The argument from ignorance, or God of the gaps, suggests that invoking God as an explanation is often a placeholder for gaps in human knowledge. Critics argue that as science progresses, these gaps shrink, reducing the need for a divine explanation. The concept of divine intervention contradicts the principle of methodological naturalism in science, which seeks natural explanations for natural phenomena. Critics argue that introducing supernatural causes undermines the consistency and predictability that science relies on. Philosophical naturalism posits that everything can be explained by natural causes and laws. Critics of religious explanations argue that invoking supernatural elements is unnecessary and that naturalistic explanations are sufficient to account for the universe's origins. The anthropic principle suggests that the universe's conditions are simply a result of the fact that we are here to observe them. Critics argue that this principle, combined with the possibility of a multiverse, provides a naturalistic explanation for the fine-tuning of the universe. Occam's razor, a philosophical principle, suggests that simpler explanations are preferable. Critics argue that the concept of God is an unnecessary complication when naturalistic explanations can suffice to explain the universe's origins. Religious explanations are also criticized for being unfalsifiable. Since they cannot be tested or potentially disproven, critics argue that they do not meet the criteria of scientific theories, which must be subject to verification and falsification. The diversity of religious creation stories is another point of criticism. With numerous conflicting accounts of the universe's origins, critics question why one particular religious explanation should be considered true over others. Some critics argue that religious explanations are anthropocentric, projecting human qualities and intentions onto the cosmos. This perspective challenges the idea that the universe is designed with human beings specifically in mind. The reliance on ancient texts for religious explanations is also criticized. Critics argue that these texts, written in a pre-scientific age, cannot adequately address modern scientific questions about the universe's origins. The problem of infinite regress is another philosophical challenge. If God created the universe, who or what created God? Critics argue that positing a divine creator simply shifts the problem of origins back one step without providing a final answer. Moral objections to religious explanations also arise, particularly regarding the behavior and commands attributed to God in various scriptures. Critics question the moral character of a creator who allows or commands suffering and violence. The advancement of scientific theories such as the Big Bang, quantum mechanics, and evolution offers naturalistic explanations for phenomena that were once attributed to divine intervention. Critics argue that these scientific theories provide more reliable and testable accounts of the universe's origins. Ultimately, critics of religious explanations advocate for a worldview based on reason, evidence, and scientific inquiry. They argue that a naturalistic approach provides a more coherent and reliable framework for understanding the universe and our place within it. The Big Bang Theory is the prevailing scientific explanation for the origin of the universe. It suggests that the universe began approximately 13.8 billion years ago from an extremely hot, dense state and has been expanding ever since. This theory is supported by a wealth of observational evidence. One of the key pieces of evidence is the cosmic microwave background radiation, which is the afterglow of the initial explosion, permeating the entire universe. The discovery of the redshift of galaxies also supports the Big Bang Theory. Observations by Edwin Hubble showed that galaxies are moving away from us, indicating that the universe is expanding. The Big Bang Theory provides a framework for understanding the formation of the universe's large-scale structure. It explains how galaxies, stars, and other cosmic structures formed from initial fluctuations in density. Cosmic nucleosynthesis is another piece of supporting evidence. This process, occurring within the first few minutes of the Big Bang, explains the abundance of light elements like hydrogen, helium, and lithium in the universe. The theory also predicts the existence of cosmic inflation, a rapid expansion of the universe in its earliest moments. This inflationary period helps explain the uniformity of the cosmic microwave background radiation. One of the challenges for the Big Bang Theory is understanding what caused the initial singularity and what, if anything, existed before it. These questions remain subjects of intense scientific inquiry and debate. The concept of dark matter is also linked to the Big Bang Theory. While dark matter doesn't emit light, its gravitational effects on visible matter, radiation, and the structure of the universe provide indirect evidence of its existence. Dark energy, another mysterious component, is thought to drive the accelerated expansion of the universe. Together with dark matter, it makes up about 95% of the universe's total energy content, posing significant questions for cosmologists. The Big Bang Theory is continually refined as new data is collected. Advances in technology, such as more powerful telescopes and satellites, allow scientists to probe deeper into the universe's history and structure. Alternative models to the Big Bang have been proposed, such as the steady-state theory, which suggests that the universe has no beginning or end, and is always expanding with matter continuously created. However, these models have not garnered as much support as the Big Bang theory. The theory also intersects with other areas of physics, including quantum mechanics and general relativity. Researchers are working to reconcile these fields with cosmological observations to develop a more comprehensive understanding of the universe. Critics of the Big Bang theory sometimes point to unresolved issues, such as the nature of dark matter and dark energy, as well as the initial conditions of the universe. However, the theory remains the most robust scientific explanation for the observable data. The philosophical implications of the Big Bang theory are profound. It suggests a universe with a finite beginning, prompting questions about causality, the nature of time, and the potential for a creator or underlying principle behind the cosmos. Ultimately, the Big Bang theory represents a monumental achievement in our quest to understand the universe. It provides a cohesive narrative for the evolution of the cosmos from its earliest moments to its current state, continuing to inspire scientific exploration and discovery. Quantum fluctuations offer a fascinating perspective on the origins of the universe. In quantum mechanics, fluctuations are temporary changes in energy that occur spontaneously in empty space, even in a vacuum. These fluctuations arise from the Heisenberg uncertainty principle, which states that certain pairs of physical properties like position and momentum cannot both be precisely known simultaneously. As a result, even empty space is never truly empty. During these quantum fluctuations, particle-antiparticle pairs can spontaneously appear and annihilate each other in incredibly short time frames. This phenomenon suggests that what we perceive as nothing is actually a seething background of activity. In the context of cosmology, some theorists propose that the universe itself could have originated from a quantum fluctuation. This idea suggests that the Big Bang was a result of a fluctuation in a primordial quantum vacuum. This hypothesis challenges traditional notions of creation, implying that the universe could emerge naturally from the laws of quantum mechanics without requiring a prior cause or divine intervention. Inflationary theory, an extension of the Big Bang, incorporates the idea of quantum fluctuations. It posits that during the universe's rapid expansion, tiny quantum fluctuations were stretched to macroscopic scales, seeding the formation of galaxies and large-scale structures. These fluctuations in the early universe left an imprint on the cosmic microwave background radiation, which we can observe today. The tiny temperature variations in this radiation map reflect the density fluctuations caused by quantum effects. The concept of a multiverse arises from the idea of quantum fluctuations. Some theories suggest that our universe is just one of many, each arising from different fluctuations in a larger quantum landscape. Quantum fluctuations also play a role in the understanding of black holes. Theoretical predictions indicate that black holes can emit radiation due to quantum effects near their event horizons, a process known as Hawking radiation. The study of quantum fluctuations bridges the gap between quantum mechanics and cosmology, challenging scientists to develop new models that can accurately describe the universe's origins and behavior on both microscopic and cosmic scales. Despite their fleeting nature, quantum fluctuations have significant implications for the fundamental nature of reality. They suggest that the universe's fabric is dynamic and constantly changing, even at the smallest scales. Quantum field theory provides the mathematical framework for understanding these fluctuations. It treats particles as excitations in underlying fields that permeate space, leading to a deeper comprehension of how matter and energy interact. The idea that the universe could emerge from a quantum fluctuation invites profound philosophical questions about existence, causality, and the nature of reality. It challenges us to rethink the concepts of creation and nothingness. Research into quantum fluctuations continues to push the boundaries of physics, inspiring new experiments and theoretical developments. As technology advances, scientists hope to uncover more about these mysterious processes and their role in the cosmos. Ultimately, quantum fluctuations reveal a universe that is far more complex and interconnected than previously imagined. They offer a glimpse into the deep underlying mechanisms that govern the emergence and evolution of the cosmos, reshaping our understanding of reality. Multiverse theory is an intriguing concept that suggests our universe is just one of many. This idea expands the scope of cosmology beyond the singular universe we observe, proposing a vast collection of universes, each with its own properties and laws of physics. One of the primary motivations for the multiverse theory comes from the inflationary model of the Big Bang. This model suggests that during the rapid expansion of the early universe, different regions could have undergone inflation at different rates, leading to the creation of multiple, separate universes. These universes, often referred to as parallel universes or alternate realities, might vary in fundamental ways. Some could have different physical constants, laws of nature, or even different numbers of dimensions, making each universe unique. The idea of a multiverse also emerges from string theory, which posits that the fundamental particles of our universe are one-dimensional strings vibrating at different frequencies. String theory's many possible solutions suggest a landscape of different possible universes, each corresponding to a different solution. Quantum mechanics offers another route to the multiverse through the many worlds interpretation. This interpretation suggests that every quantum event spawns multiple, branching universes, each representing a different outcome of that event. According to this view, all possible outcomes of quantum events actually occur in separate, parallel universes. The concept of the multiverse helps address certain fine-tuning problems in cosmology. For example, the precise conditions necessary for life in our universe might seem improbably fine-tuned, but if there are countless universes with varying properties, it becomes more plausible that at least one would have the right conditions for life. Cosmologists like Andre Linde have contributed significantly to multiverse theory, proposing models where our observable universe is just one bubble in a vast cosmic foam of bubble universes. Each bubble represents a different universe, potentially with its own laws of physics. While the multiverse theory is compelling, it also faces significant challenges. One major issue is the lack of direct observational evidence. Since other universes would be beyond our observable horizon, testing the multiverse theory experimentally is extremely difficult. Philosophically, the multiverse theory raises profound questions about the nature of reality and our place in it. If countless other universes exist, it challenges the uniqueness of our own universe and our understanding of existence. Critics argue that the multiverse theory, while mathematically and theoretically intriguing, may not be scientifically falsifiable. This raises debates about whether it can be considered a legitimate scientific theory or remains in the realm of speculative philosophy. Despite these challenges, the multiverse theory continues to inspire scientific and philosophical inquiry. It pushes the boundaries of our understanding and encourages the exploration of new ideas about the cosmos and our existence within it. Proponents of the multiverse theory suggest that indirect evidence might be found through anomalies in the cosmic microwave background radiation or other cosmological observations that hint at interactions with other universes. Some researchers explore the implications of the multiverse for concepts like entropy and the arrow of time. They speculate that different universes might have different entropic histories, which could provide insights into the nature of time itself. The multiverse theory also finds a place in popular culture, inspiring countless works of science fiction and fantasy. These stories explore the possibilities of alternate realities and parallel worlds, reflecting our deep fascination with the idea. Ultimately, the multiverse theory represents a bold and imaginative leap in our quest to understand the cosmos. Whether it turns out to be a profound truth about the nature of reality or a speculative idea, it challenges us to think beyond the confines of our observable universe and consider the vast possibilities that might lie beyond. Cosmological models are essential tools for understanding the structure and evolution of the universe. These models use mathematics and physical laws to describe how the cosmos behaves on the largest scales. One of the most prominent cosmological models is the lambda cold dark matter model, or lambda CDM. This model includes dark energy, represented by the cosmological constant lambda, and cold dark matter, which moves slowly compared to the speed of light. Lambda CDM successfully explains many observations, such as the cosmic microwave background radiation, the large-scale structure of the universe, and the distribution of galaxies. It serves as the standard model of cosmology. Another important model is the Friedmann-Lemaitre-Robertson-Walker, or FLRW model. This model describes a homogeneous and isotropic universe, meaning it looks the same in all directions and at all points. It's based on solutions to Einstein's field equations of general relativity. Inflationary models propose a rapid expansion of the universe in its very early moments. This inflation smooths out any initial irregularities and leads to the large-scale uniformity we observe today. Alan Guth first proposed the idea of cosmic inflation in the early 1980s. The steady-state model, once a competitor to the Big Bang theory, posits that the universe has no beginning or end and is always expanding. Matter is continuously created to maintain a constant density. Although this model has largely fallen out of favor, it contributed significantly to early cosmological debates. The ekpyrotic model suggests that the universe originated from the collision of two three-dimensional worlds in a higher dimensional space. This model aims to address some of the problems faced by traditional inflationary theories, such as the initial singularity. Brane cosmology is another intriguing model, rooted in string theory. It posits that our universe exists on a brane, a multidimensional object, within a higher dimensional space. Interactions between branes can explain cosmic phenomena and offer alternative explanations for the Big Bang. Loop quantum cosmology applies principles from loop quantum gravity to cosmology. This model suggests that space-time has a discrete structure at the smallest scales, potentially avoiding the initial singularity of the Big Bang and predicting a cyclical universe. The holographic principle is a radical idea that suggests the entire universe can be described as a two-dimensional information structure on the cosmological horizon. This principle arises from considerations of black hole entropy and string theory. Quintessence models propose a dynamic form of dark energy, unlike the static cosmological constant in lambda CDM. In these models, dark energy evolves over time, influencing the expansion rate of the universe in a more complex way. Modified Newtonian dynamics, or MOEND, is an alternative to dark matter theories. It suggests that the laws of gravity change at very low accelerations, explaining the rotational speeds of galaxies without invoking dark matter. The Milne model, an early 20th century idea, describes a universe expanding without matter or radiation. While not physically accurate, it provides interesting insights into the geometry of spacetime. The Einstein static universe was an early attempt by Einstein to describe a stable universe. It included a cosmological constant to counteract gravity and achieve a static solution, but it was later abandoned in favor of dynamic models. Bianchi models generalize the FLRW model to allow for anisotropy, meaning the universe can look different in different directions. These models explore how small deviations from uniformity might evolve. Cosmological models are constantly refined as new observations are made. Each model offers unique insights into the workings of the universe, helping us understand its past, present, and potential future. These models demonstrate the power of theoretical physics in unraveling the mysteries of the cosmos. Scientific theories, while powerful, have inherent limitations that shape our understanding of the universe. One major limitation is the inability to directly observe the earliest moments of the Big Bang. Our current models are based on extrapolations from later observations, leaving the true nature of the initial singularity shrouded in mystery. Another limitation is the challenge of unifying general relativity and quantum mechanics. These two pillars of modern physics work well in their respective domains, but are fundamentally incompatible when describing the universe's earlier state, where both quantum effects and strong gravitational fields are significant. Dark matter and dark energy present significant challenges. While their existence is inferred from gravitational effects and the accelerated expansion of the universe, they remain undetected and poorly understood. This gap in knowledge limits our understanding of the universe's true composition and behavior. Scientific theories also face the limitation of observational horizons. The observable universe is finite, meaning we cannot see beyond a certain distance. This horizon limits our ability to fully understand the structure and scale of the entire cosmos. The accuracy of scientific theories depends on the precision of measurements and instruments. Technological limitations can restrict the resolution and scope of our observations, potentially leading to incomplete or skewed understandings of cosmic phenomena. Assumptions and simplifications are necessary in scientific modeling, but they can introduce limitations. For example, the assumption of a homogeneous and isotropic universe in cosmological models might overlook important local variations and complexities. Theoretical predictions often rely on idealized conditions that may not perfectly match reality. This reliance can lead to discrepancies between models and observations, necessitating constant refinement and revision of theories. Scientific theories are also constrained by current mathematical frameworks. Some aspects of the universe might require new or more advanced mathematical tools to fully describe and understand, indicating that our current models are provisional and subject to change. Interpreting cosmological data involves significant uncertainty. Measurements of cosmic microwave background radiation, galaxy distribution, and other key data come with error margins that can affect the conclusions drawn from them. The nature of scientific inquiry itself imposes limitations. Science is an iterative process of hypothesis, testing, and revision. This means that our current theories are always subject to change as new evidence emerges, highlighting their provisional nature. The philosophical implications of scientific theories also pose limitations. Questions about the ultimate origin of the universe, the nature of reality, and the existence of a multiverse often extend beyond the empirical scope of science, entering the realm of metaphysics and philosophy. Cultural and cognitive biases can influence scientific theories. The history of science shows that prevailing worldviews and biases can shape the development and acceptance of theories, potentially limiting the objectivity of scientific inquiry. The interpretation of phenomena like quantum mechanics introduces paradoxes and conceptual challenges. Concepts such as wave-particle duality, entanglement, and superposition challenge classical notions of reality, indicating that our understanding of these phenomena is incomplete. Long-term predictions in cosmology are inherently uncertain. While current models can describe past and present cosmic behavior, predicting the distant future involves assumptions about the constancy of physical laws and the unknown nature of dark energy. Finally, the interplay between science and technology means that scientific progress often depends on technological advancements. Limitations in technology can therefore constrain scientific theories and their ability to describe and explain the universe comprehensively. In conclusion, while scientific theories provide profound insights into the nature of the universe, they are inherently limited by observational, conceptual, and technological constraints. Recognizing these limitations is crucial for advancing our understanding and continuing the pursuit of knowledge about the cosmos. The cosmological argument is a classical argument for the existence of God that seeks to explain the existence of the universe. It begins with the premise that everything that exists has a cause of its existence. One of the most well-known formulations of the cosmological argument is the Kalam cosmological argument. It states that everything that begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. This cause, proponents argue, must be an uncaused, necessary being that exists outside of time and space. This being is identified as God, who initiates the existence of the universe. The argument also includes the concept of contingency. It suggests that everything in the universe is contingent, meaning it depends on something else for its existence. There must be a necessary being on which everything contingent relies, and this necessary being is God. Thomas Aquinas offered another form of the cosmological argument in his 5 ways. His first 3 ways, the arguments from motion, causation, and contingency, all build upon the idea that the existence of the universe requires a first cause or a necessary being, which he identifies as God. The argument from motion asserts that everything in motion must be set in motion by something else. Since there cannot be an infinite regress of movers, there must be a first unmoved mover, which is God. The argument from causation posits that every effect has a cause. Since there cannot be an infinite chain of causes, there must be a first uncaused cause, which is God. The argument from contingency observes that all beings in the universe are contingent. If everything were contingent, there could have been a time when nothing existed. Therefore, there must be a necessary being whose existence is not contingent on anything else, and this being is God. Critics of the cosmological argument question the necessity of a first cause. They argue that the universe could be self-sustaining, or that the chain of causes could be infinite, challenging the need for a divine initiator. Some also challenge the leap from identifying a first cause to defining it as the God of classical theism. They argue that even if the argument successfully identifies a cause, it does not necessarily entail the characteristics attributed to God, such as omniscience, omnipotence, and benevolence. The cosmological argument faces scrutiny from the problem of infinite regress. Critics argue that if everything needs a cause, then God too would need a cause, leading to an infinite regress that the argument itself seeks to avoid. Defenders of the argument respond by asserting that God is a necessary being, existing outside the chain of contingent causes, and therefore does not require a cause. This necessary existence is what sets God apart from the contingent universe. The cosmological argument also engages with modern cosmology. Some proponents use the Big Bang theory as evidence for the universe having a beginning, thereby supporting the need for a first cause. However, some cosmologists argue that the Big Bang does not necessarily imply a beginning in the traditional sense, as time itself began with the Big Bang, making it a boundary rather than a point of creation. Ultimately, the cosmological argument is a foundational piece of natural theology. It continues to provoke discussion and debate, bridging the realms of philosophy, theology, and science in the quest to understand the existence of the universe and the possibility of a divine creator. The ontological argument is a philosophical argument for the existence of God that is based on reason and logic rather than empirical evidence. It was first proposed by Anselm of Canterbury in the 11th century. Anselm defined God as that than which nothing greater can be conceived. He argued that this definition must exist not only in the mind but also in reality, because a God that exists in reality is greater than one that exists only in the mind. Anselm's argument hinges on the idea that existence is a perfection. If God is the greatest conceivable being, then God must possess all perfections, including existence. Therefore, God must exist. René Descartes later developed his own version of the ontological argument. He argued that the existence of God is self-evident, similar to the way the properties of geometric shapes are self-evident. Just as a triangle must have three sides, God must exist as a perfect being. The ontological argument is unique because it is an a priori argument. This means it relies on reasoning and logic rather than observations or empirical evidence. It seeks to prove God's existence through the definition and concept of God itself. Critics of the ontological argument, such as Immanuel Kant, have argued that existence is not a predicate or a property that can be attributed to a being. Kant asserted that adding existence to the concept of a being does not make it any greater. Another criticism comes from the philosopher David Hume, who argued that just because we can conceive of a perfect being does not mean that such a being exists in reality. Conceivability does not necessarily entail actual existence. Gonilo of Marmoutier, a contemporary of Anselm, criticized the argument using the example of a perfect island. He argued that by Anselm's logic, one could conceive of the greatest possible island, but that does not mean such an island exists in reality. Modern philosophers like Alvin Plantinga have offered revised versions of the ontological argument. Plantinga's modal version suggests that if it is possible that a maximally great being exists, then such a being exists in some possible world. If a maximally great being exists in some possible world, it exists in every possible world, including our own. Plantinga's version aims to address some of the classical criticisms by framing the argument in terms of modal logic, which deals with possibility and necessity. Despite its criticisms, the ontological argument remains a significant topic in philosophy. It has sparked extensive debate and has been the subject of numerous interpretations and reformulations over the centuries. The ontological argument also engages with the concept of necessary existence. It posits that God, as a maximally great being, must exist necessarily rather than contingently, meaning that God's non-existence is impossible. Philosophers continue to explore the implications of the ontological argument, examining its logical structure and its impact on the broader discourse about the nature of existence and the divine. The argument challenges us to think deeply about the relationship between concepts and reality, the nature of perfection, and the limits of human reason in addressing metaphysical questions. Ultimately, the ontological argument is a testament to the enduring human quest to understand the nature of God and the foundations of existence. Whether one finds it compelling or flawed, it remains a cornerstone of philosophical theology and a profound exercise in reasoning about the divine. The teleological argument, also known as the argument from design, suggests that the order and complexity of the universe indicate the presence of a purposeful creator. It is one of the oldest and most intuitive arguments for the existence of God. One of the most famous proponents of the teleological argument was William Paley. He used the analogy of a watchmaker, arguing that just as the complexity of a watch implies an intelligent designer, so too does the complexity of the universe imply a divine creator. Paley's argument is based on the intricate structures found in nature. He pointed to the complexity of biological organisms, the precise conditions necessary for life, and the harmonious laws of physics as evidence of intentional design. Modern proponents of the teleological argument often focus on the fine-tuning of the universe. They argue that the fundamental constants and laws of nature are precisely calibrated to allow for the existence of life. This fine-tuning is seen as highly improbable, without the guidance of an intelligent designer. The argument from fine-tuning suggests that small changes in the values of these constants would make life impossible. Proponents claim that the best explanation for this fine-tuning is the existence of a designer who set these parameters intentionally. Critics of the teleological argument, such as David Hume, argue that the appearance of design can be explained by natural processes. Hume suggested that the complexity we observe could arise from the gradual process of evolution and natural selection, rather than requiring a divine designer. Charles Darwin's theory of evolution by natural selection provides a naturalistic explanation for the complexity and adaptation of biological organisms. It shows how simple life forms can evolve into more complex ones over time through random mutations and selective pressures. Another criticism comes from the concept of multiple universes, or the multiverse. Some physicists suggest that if there are countless universes with varying physical constants, it is not surprising that at least one, like ours, has the right conditions for life. Richard Dawkins, a prominent atheist and evolutionary biologist, argues that natural selection is a blind process that does not require any foresight or planning. He contends that biological complexity can be fully explained by evolution without invoking a designer. The anthropic principle also challenges the teleological argument. It states that we should not be surprised to find ourselves in a universe capable of supporting life, because if it were otherwise, we would not be here to observe it. Thus, the conditions for life are simply a prerequisite for our existence. Despite these criticisms, the teleological argument continues to be influential. Many people find the apparent design and order of the universe compelling evidence for the existence of God. It resonates with our intuition that complex systems require a designer. The argument is also supported by the discoveries in fields such as physics, chemistry, and astronomy, which reveal the delicate balance necessary for life. Proponents argue that the more we learn about the universe, the more it seems to point toward intentional design. Some modern versions of the teleological argument incorporate insights from information theory. They suggest that the complex information encoded in DNA and the functioning of biological systems indicate the presence of an intelligent source. Philosophers and theologians continue to debate the validity and implications of the teleological argument. It raises important questions about the nature of the universe, the possibility of purpose, and the existence of a creator. Ultimately, the teleological argument invites us to reflect on the order and beauty of the cosmos. Whether one finds it convincing or not, it remains a central topic in discussions about the existence of God and the interpretation of the natural world. The moral argument for the existence of God suggests that objective moral values and duties point to the existence of a divine source. It posits that without a transcendent foundation, moral principles would lack grounding and objectivity. One formulation of the moral argument comes from Immanuel Kant, who argued that the existence of moral obligations implies the existence of a moral lawgiver. He believed that the categorical imperative, which commands us to act according to universalizable principles, necessitates the existence of a supreme lawmaker. C.S. Lewis offered a similar argument in his book, Mere Christianity. He posited that the existence of a universal moral law points to the existence of a moral lawgiver. He argued that this lawgiver is God, who provides the objective basis for morality. The moral argument also draws on the concept of moral realism, which posits that moral facts are objective features of the world, independent of human beliefs or preferences. Proponents argue that the existence of objective moral values implies the existence of a transcendent source for these values. Critics of the moral argument challenge the idea that objective moral values require a divine foundation. Some argue that moral values can be explained in evolutionary terms, as adaptations that promote social cohesion and cooperation. Others point to cultural relativism as evidence that moral values are not universally objective, but are instead shaped by cultural norms and beliefs. They argue that the diversity of moral codes across different societies undermines the claim that morality is grounded in a transcendent source. The Euthyphro dilemma, named after a dialogue by Plato, poses a challenge to the moral argument. It asks whether something is morally good because God commands it, or if God commands it because it is morally good. If the former is true, it implies that morality is arbitrary and could change based on God's whims. If the latter is true, it suggests that moral standards exist independently of God. Some critics argue that appealing to God as the source of morality raises further questions about the nature of God and the relationship between divine command and moral obligation. They question whether an all-powerful and benevolent God would command actions that seem morally objectionable. Defenders of the moral argument respond by asserting that God's nature is inherently good, and therefore his commands reflect objective, moral values. They argue that God's commands are consistent with his nature and provide a foundation for objective moral obligations. The moral argument also engages with the concept of human dignity and rights. Proponents argue that the belief in inherent human worth and dignity is best explained by the existence of a divine creator who imbues humans with intrinsic value. The universality of certain moral intuitions, such as the prohibition against murder and the value of kindness, is seen as evidence for the existence of objective and moral values. Proponents argue that these intuitions point to a common moral law written on the human heart, as described by theologians like Augustine. Some defenders of the moral argument point to the existence of moral progress as evidence for objective moral values. They argue that moral progress implies a standard of moral excellence that transcends cultural and historical context, suggesting a universal moral law. The moral argument also intersects with discussions about free will and moral responsibility. Proponents argue that the existence of moral obligations implies the existence of free will, and that free will is best explained by the existence of a divine creator who grants humans the capacity for moral choice. Ultimately, the moral argument invites us to consider the nature and foundation of morality. Whether one finds it convincing or not, it raises important questions about the source of moral values, the nature of obligation, and the existence of a transcendent moral lawgiver. Critiques of philosophical arguments for the existence of God abound, challenging the premises, logic, and conclusions of these arguments. One common critique is the issue of circular reasoning, where the conclusion of the argument is assumed in one of the premises. Another critique is the anthropocentric nature of some arguments, which rely on human intuitions and perceptions of order and purpose in the universe. Critics argue that these intuitions may not accurately reflect the true nature of reality and could be biased by human cognitive limitations. Some critics challenge the coherence of the concept of God presented in philosophical arguments. They argue that the attributes ascribed to God, such as omnipotence, omniscience, and benevolence, are internally inconsistent and lead to logical paradoxes. Critics also question the relevance of philosophical arguments in light of scientific explanations for the origins and nature of the universe. They argue that empirical evidence should take precedence over abstract reasoning when addressing questions about the existence of God. The problem of evil presents a significant challenge to philosophical arguments for the existence of God. Critics argue that the existence of suffering and injustice in the world is incompatible with the existence of an all-powerful and benevolent God. The lack of consensus among philosophers about the validity of these arguments undermines their persuasive power. While some philosophers find certain arguments compelling, others remain unconvinced, indicating that philosophical arguments alone may not provide definitive answers to questions about the existence of God. Some critics argue that philosophical arguments for the existence of God rely on speculative metaphysical assumptions that cannot be empirically verified or falsified. This reliance on metaphysics makes these arguments vulnerable to skepticism and doubt. The diversity of religious beliefs and interpretations further complicates philosophical discussions about the existence of God. Different religious traditions offer competing explanations and conceptions of the divine, making it challenging to arrive at a consensus through philosophical reasoning alone. Critics also point to the limitations of human language and concepts when discussing metaphysical questions about the nature of God. They argue that human language is inherently finite and inadequate to capture the complexity and mystery of the divine. The problem of divine hiddenness raises questions about why an omnipotent and loving God would not provide more direct evidence of his existence. Critics argue that the lack of clear and unambiguous evidence for God's existence undermines the credibility of philosophical arguments. The influence of cultural and historical factors on philosophical arguments for the existence of God cannot be overlooked. Critics argue that philosophical arguments are often shaped by the cultural and intellectual context in which they emerge, raising questions about their universality and objectivity. Some critics challenge the coherence of the concept of God presented in philosophical arguments. They argue that the attributes ascribed to God, such as omnipotence, omniscience, and benevolence, are internally inconsistent and lead to logical paradoxes. Critics also question the relevance of philosophical arguments in light of scientific explanations for the origins and nature of the universe. They argue that empirical evidence should take precedence over abstract reasoning when addressing questions about the existence of God. The problem of evil presents a significant challenge to philosophical arguments for the existence of God. Critics argue that the existence of suffering and injustice in the world is incompatible with the existence of an all-powerful and benevolent God. The lack of consensus among philosophers about the validity of these arguments undermines their persuasive power. While some philosophers find certain arguments compelling, others remain unconvinced, indicating that philosophical arguments alone may not provide definitive answers to questions about the existence of God. Some critics argue that philosophical arguments for the existence of God rely on speculative metaphysical assumptions that cannot be empirically verified or falsified. This reliance on metaphysics makes these arguments vulnerable to skepticism and doubt. Throughout history, conflicts over religious beliefs have been a recurring theme, leading to wars, persecution, and social divisions. These conflicts often stem from differences in religious doctrines, practices, and interpretations. One of the most notable historical conflicts is the Crusades, a series of religious wars fought between Christians and Muslims over control of holy sites in the Middle East. The Crusades resulted in significant loss of life and deep-seated animosities that persist to this day. The Reformation in the 16th century sparked religious conflicts across Europe, as Protestant reformers challenged the authority of the Catholic Church. These conflicts, including the 30 Years' War, led to widespread violence and persecution as rulers and populations aligned with different religious factions. Colonial expansion brought religious conflicts to new territories, as European powers imposed their faith on indigenous populations. Missionary efforts often led to cultural clashes and violence, as native beliefs and practices were suppressed in favor of Christianity. The Protestant-Catholic conflicts in Ireland, known as the Troubles, have been a source of sectarian violence and political strife for centuries. These conflicts, rooted in historical grievances and competing religious identities, continue to shape Northern Irish society. The Spanish Inquisition, initiated by Catholic monarchs to root out heresy and enforce religious conformity, resulted in the persecution and execution of thousands of Jews, Muslims, and suspected heretics. The Inquisition represents a dark chapter in the history of religious intolerance and oppression. The Salem witch trials in colonial America were another example of religious conflict, leading to mass hysteria and persecution. Fear of witchcraft and religious zealotry fueled accusations and trials that resulted in the execution of innocent people. Conflicts between religious and secular authorities have also been prevalent throughout history. The struggle for power and influence between church and state has led to clashes over issues such as governance, morality, and religious freedom. The Enlightenment brought about a period of intellectual and philosophical upheaval that challenged traditional religious beliefs and institutions. The rise of secularism and skepticism undermined the authority of religious institutions and contributed to conflicts between religious and secular worldviews. The rise of nationalism in the 19th and 20th centuries fueled conflicts over religious identity and autonomy. Ethnic and religious minorities often faced discrimination and persecution as nationalist movements sought to establish homogeneous nation-states. The Israeli-Palestinian conflict is a modern-day example of a complex religious and political struggle over land, identity, and sovereignty. The conflict, rooted in competing claims to historical and religious heritage, has resulted in decades of violence and unrest. In recent years, conflicts between religious fundamentalists and secular governments have escalated in various parts of the world. Issues such as blasphemy laws, religious extremism, and the role of religion in public life have fueled tensions and violence. The rise of terrorism, often justified in the name of religion, has further exacerbated religious conflicts and polarized communities. Extremist groups such as ISIS have carried out attacks targeting religious minorities and symbols of secularism. Social media and digital communication have amplified religious conflicts by facilitating the spread of extremist ideologies and inflammatory rhetoric. Online platforms have become battlegrounds for religious propaganda and recruitment efforts. Efforts to promote interfaith dialogue and understanding have emerged as a response to religious conflicts. Interfaith initiatives seek to foster mutual respect, cooperation, and peaceful coexistence among people of different religious backgrounds. Despite these efforts, religious conflicts persist in various forms, highlighting the enduring challenges of reconciling religious diversity and promoting tolerance in an increasingly interconnected world. Despite the historical and ongoing conflicts over religious beliefs, there are also areas of agreement and common ground among different religious traditions. One such area is the promotion of ethical principles and moral values that emphasize compassion, justice, and altruism. Many religious traditions advocate for the importance of charity and helping those in need, regardless of their religious affiliation. Acts of kindness and generosity are seen as central to living a virtuous and meaningful life. Another area of agreement is the recognition of the value of community and fellowship. Religious communities provide a sense of belonging, support, and solidarity to their members, fostering bonds of friendship and mutual care. The pursuit of spiritual growth and self-improvement is another common theme across religious traditions. Practices such as prayer, meditation, and reflection are seen as essential for cultivating inner peace, wisdom, and personal transformation. Many religions also share a reverence for the natural world and a sense of stewardship toward the environment. Respect for nature and the belief in its sacredness are reflected in rituals, ceremonies, and ethical teachings that promote environmental sustainability and conservation. The promotion of peace and reconciliation is another area of agreement among religious traditions. While conflicts have often been fueled by religious differences, many religious leaders and communities advocate for peace-building, dialogue, and conflict resolution. Interfaith dialogue and cooperation have become increasingly important in addressing shared global challenges, such as poverty, inequality, and climate change. Collaborative efforts among religious groups can lead to greater understanding, cooperation, and social cohesion. Many religious traditions emphasize the importance of forgiveness and reconciliation as pathways to healing and reconciliation. Forgiveness is seen as a transformative practice that promotes healing, reconciliation, and the restoration of relationships. The pursuit of knowledge, wisdom, and spiritual understanding is another area of agreement among religious traditions. Many religions value intellectual inquiry, education, and the search for truth as essential aspects of spiritual growth and enlightenment. The celebration of diversity and the recognition of the inherent worth and dignity of every individual are common themes across religious traditions. Respect for human rights, equality, and dignity are fundamental principles that underpin ethical teachings and social justice advocacy. The promotion of social justice and the alleviation of suffering are central concerns for many religious traditions. Advocacy for the marginalized, oppressed, and vulnerable is seen as a moral imperative rooted in compassion and solidarity. Many religious traditions share a commitment to peace-building and conflict resolution through non-violent means. Dialogue, negotiation, and mediation are valued as tools for resolving conflicts and promoting reconciliation. The pursuit of peace and harmony within oneself and with others is a central theme in many religious traditions. Practices such as mindfulness, meditation, and prayer are seen as pathways to inner peace, emotional well-being, and spiritual fulfillment. The recognition of the interconnectedness of all life and the importance of cultivating compassion and empathy are common themes across religious traditions. The ethic of reciprocity, often expressed as the Golden Rule, is a universal principle that emphasizes treating others with kindness and respect. Ultimately, while religious traditions may differ in their beliefs, practices, and rituals, they often share common values and aspirations that transcend cultural and religious boundaries. By recognizing and celebrating these areas of agreement, people of diverse faiths can work together to build a more compassionate, just, and peaceful world. Throughout history, numerous influential thinkers have shaped our understanding of religion, philosophy, and the human experience. These thinkers have explored fundamental questions about the nature of existence, the meaning of life, and the role of religion in society. One such influential thinker is Plato, whose dialogues explored the nature of reality, knowledge, and the soul. His ideas about the forms, the allegory of the cave, and the tripartite soul continue to influence philosophical discourse. Aristotle, Plato's student, made significant contributions to ethics, metaphysics, and logic. His concept of virtue ethics, the doctrine of the mean, and his exploration of causality laid the foundation for Western philosophical thought. Thomas Aquinas, a medieval theologian, synthesized Christian theology with Aristotelian philosophy in his seminal work, the Summa Theologica. His ideas about natural law, the existence of God, and the relationship between faith and reason have had a profound impact on Western thought. René Descartes, a French philosopher, is known for his method of doubt and his famous dictum, cogito ergo sum, I think, therefore I am. His dualistic philosophy of mind-body dualism and his rationalist approach to knowledge influenced subsequent generations of philosophers. Immanuel Kant, an Enlightenment philosopher, revolutionized moral philosophy with his concept of the categorical imperative and his theory of transcendental idealism. His ideas about autonomy, freedom, and the limits of human knowledge continue to shape philosophical inquiry. Friedrich Nietzsche, a German philosopher, challenged traditional moral values and religious beliefs in his critique of Christianity and his concept of the will to power. His ideas about the death of God and the Übermensch have had a profound impact on existentialist thought. Søren Kierkegaard, a Danish philosopher, is considered the father of existentialism for his exploration of individuality, subjectivity, and faith. His ideas about the leap of faith, the existential angst, and the importance of authenticity resonate with modern readers. Jean-Paul Sartre, a French philosopher, further developed existentialist thought with his concept of radical freedom and his existentialist slogan, "Existence precedes essence." His ideas about the absurdity of existence and the responsibility of individuals have had a lasting influence. Martin Heidegger, a German philosopher, explored the meaning of being in his existential phenomenology and his concept of Dasein, being there. His critique of modernity and his analysis of human existence continue to provoke philosophical debate. Simone de Beauvoir, a French existentialist philosopher, examined the role of women in society and the concept of gender in her seminal work, The Second Sex. Her ideas about freedom, ambiguity, and the social construction of identity have shaped feminist thought. Albert Camus, a French Algerian philosopher, explored the human condition in his philosophy of absurdism and his novels such as The Stranger and The Myth of Sisyphus. His ideas about the absurdity of life and the search for meaning continue to resonate with readers. Hannah Arendt, a German-American philosopher, analyzed the nature of totalitarianism and the human condition in the 20th century. Her ideas about the banality of evil, the importance of political action, and the concept of the human condition have influenced political theory and ethics. Michel Foucault, a French philosopher, examined the relationship between power, knowledge, and discourse in his critical analyses of institutions such as prisons, hospitals, and schools. His ideas about the construction of truth and the operation of power continue to shape critical theory. Richard Dawkins, a British evolutionary biologist, is known for his advocacy of atheism and his critique of religion in books such as The God Delusion. His ideas about natural selection, the selfish gene, and the meme have had a significant impact on discussions about science, religion, and ethics. Ayn Rand, a Russian-American philosopher, promoted a philosophy of objectivism that emphasized rational self-interest, individualism, and laissez-faire capitalism. Her ideas about egoism, reason, and the pursuit of happiness have influenced libertarianism and free market ideology. In the modern era, dialogue between religious and secular perspectives has become increasingly important as societies grapple with complex ethical, social, and political issues. This dialogue seeks to foster mutual understanding, respect, and cooperation among people of diverse worldviews. Interfaith dialogue brings together representatives from different religious traditions to discuss shared values, promote peace, and address common challenges. These dialogues often focus on areas of agreement, such as social justice, environmental stewardship, and human rights. Interreligious dialogue also explores theological differences and seeks to promote greater understanding and tolerance among religious communities. By engaging in respectful dialogue, participants can gain insights into the beliefs and practices of others while affirming their own faith traditions. Interfaith initiatives often involve collaborative efforts to address social issues such as poverty, conflict resolution, and disaster relief. By working together across religious boundaries, communities can leverage their collective resources and expertise to make a positive impact. Dialogue between religious and secular perspectives is also essential for addressing contemporary ethical dilemmas such as bioethics, reproductive rights, and end-of-life care. By engaging in reasoned discourse, stakeholders can find common ground and develop ethical guidelines that respect diverse beliefs and values. Secular humanism, with its emphasis on reason, science, and human rights, offers a valuable perspective in dialogue with religious traditions. Secular humanists advocate for the separation of church and state and the promotion of secular ethics based on universal principles of justice and compassion. At the same time, religious communities can learn from secular perspectives on issues such as gender equality, LGBTQ rights, and religious pluralism. By engaging with secular critiques, religious institutions can evolve and adapt to the changing social and cultural landscape. Dialogue between religious and secular perspectives also plays a crucial role in promoting religious freedom and combating religious extremism and intolerance. By fostering understanding and respect, communities can work together to safeguard fundamental human rights and freedoms. In academia, interdisciplinary dialogue between religious studies, philosophy, science, and other disciplines enriches our understanding of religion and its role in society. Scholars from diverse backgrounds contribute insights and perspectives that challenge and complement each other. Dialogue between religious and secular perspectives is not without challenges, including misunderstandings, stereotypes, and ideological divisions. However, through patient listening, empathy, and open-mindedness, participants can overcome these obstacles and build bridges of understanding. Social media and digital technology have also transformed the landscape of dialogue, providing platforms for people to connect, share ideas, and engage in discussions across geographical and cultural boundaries. These tools offer new opportunities for dialogue and collaboration. In the public sphere, dialogue between religious and secular perspectives is essential for promoting pluralism, democracy, and human rights. By fostering a culture of dialogue and respect, societies can create inclusive spaces where diverse voices are heard and valued. Civil society organizations, including religious and secular NGOs, play a crucial role in facilitating dialogue and cooperation among different stakeholders. These organizations often work on issues such as peace-building, interfaith harmony, and social justice. Educational institutions have a responsibility to promote dialogue and critical thinking about religion and secularism. By incorporating religious studies, ethics, and comparative religion into the curriculum, schools can equip students with the knowledge and skills to engage thoughtfully with diverse perspectives. In conclusion, dialogue between religious and secular perspectives is essential for promoting mutual understanding, respect, and cooperation in our increasingly diverse and interconnected world. By engaging in dialogue, we can build bridges of understanding and work together to address shared challenges and create a more just and compassionate society. Stephen Hawking, a renowned theoretical physicist, revolutionized our understanding of the cosmos with his groundbreaking work on black holes, the Big Bang, and the nature of time. His contributions to cosmology, quantum mechanics, and gravitational physics have had a profound impact on our scientific worldview. Hawking's most famous work, A Brief History of Time, became an international bestseller and brought complex scientific concepts to a broader audience. In it, he explored the origins of the universe, the nature of space and time, and the fundamental laws that govern the cosmos. Hawking's research on black holes challenged conventional wisdom and led to the discovery of groundbreaking phenomena such as Hawking radiation, which suggested that black holes are not entirely black, but emit radiation due to quantum effects near their event horizons. Despite being diagnosed with a motor neuron disease at a young age, Hawking continued to pursue his scientific research with determination and perseverance. His resilience in the face of adversity inspired millions of people around the world. Hawking's contributions to theoretical physics earned him numerous awards and honors, including the Albert Einstein Award, the Presidential Medal of Freedom, and the Fundamental Physics Prize. His work has left an indelible mark on the scientific community and continues to influence research in cosmology and theoretical physics. Hawking's scientific discoveries have also sparked philosophical reflections on the nature of the universe, the existence of God, and the limits of human knowledge. His exploration of the origins and fate of the cosmos raised profound questions about our place in the universe and the ultimate meaning of existence. Hawking's advocacy for science education and his efforts to popularize science made him a beloved figure worldwide. Through his books, lectures, and media appearances, he sought to inspire curiosity and promote scientific literacy among people of all ages. Hawking's wit, humor, and irreverence endeared him to audiences around the world. Despite grappling with a debilitating illness, he maintained a sharp intellect, a keen sense of humor, and a zest for life that inspired admiration and affection. Hawking's contributions to the public understanding of science and his efforts to communicate complex scientific ideas in accessible ways have made him a cultural icon and a role model for aspiring scientists and science enthusiasts. Hawking's legacy extends beyond his scientific achievements to his advocacy for global challenges, such as climate change, space exploration, and the search for extraterrestrial life. He believed that science and reason could help humanity address pressing issues and build a better future for generations to come. Hawking's bold ideas and fearless pursuit of knowledge challenged conventional thinking and pushed the boundaries of human understanding. His willingness to question received wisdom and explore the unknown inspired a new generation of scientists and thinkers. Hawking's life and work serve as a reminder of the power of the human spirit to triumph over adversity and to unlock the mysteries of the universe. His legacy will continue to inspire curiosity, wonder, and exploration for generations to come. Hawking's passing in 2018 marked the end of an era in theoretical physics, but his influence and legacy endure. His contributions to science and his passion for understanding the cosmos have left an indelible mark on the scientific community and on humanity as a whole. In conclusion, Stephen Hawking's groundbreaking discoveries, his advocacy for science education, and his indomitable spirit have made him one of the most influential figures in modern science. His legacy will continue to inspire and guide future generations of scientists and thinkers as they explore the mysteries of the universe. Richard Dawkins, an evolutionary biologist and prominent atheist, has been a leading voice in the public discourse on science, religion, and rationality. His influential books, such as The Selfish Gene and The God Delusion, have sparked widespread debate and controversy. Dawkins' concept of the selfish gene revolutionized our understanding of evolution by emphasizing the role of genes in driving behavior and natural selection. His gene-centered view of evolution challenged traditional notions of altruism and cooperation in biology. In The God Delusion, Dawkins argued against the existence of a deity and criticized organized religion for its dogma, superstition, and intolerance. His book sparked fierce debate and criticism from religious believers and intellectuals alike. Dawkins's advocacy for atheism and secularism has made him a polarizing figure in the ongoing debate over the role of religion in society. His outspoken criticism of religious beliefs and practices has earned him both admirers and detractors. Dawkins's scientific research on evolution and genetics has earned him widespread acclaim and recognition in the scientific community. His work has shed light on the mechanisms of evolution and the origins of biodiversity. Dawkins's popularization of science and his efforts to promote scientific literacy have made him a leading figure in the movement to combat pseudoscience, superstition, and misinformation. His books, lectures, and media appearances have inspired countless people to embrace reason and critical thinking. Dawkins' concept of the meme, an idea or cultural phenomenon that spreads through imitation, has influenced fields such as psychology, sociology, and cultural studies. His exploration of memes has shed light on the transmission of ideas and behaviors in human societies. Dawkins' advocacy for secularism and the separation of church and state has led him to campaign against religious influence in education, politics, and public policy. He has argued for the importance of evidence-based decision-making and rational discourse in shaping public policy. Dawkins' critique of religion as a source of conflict, oppression, and irrationality has resonated with many secularists, atheists, and humanists. His defense of reason, science, and humanism has galvanized a new generation of skeptics and freethinkers. Dawkins' debates with religious apologists and theologians have become legendary for their intensity and intellectual rigor. His confrontational style and sharp wit have earned him a reputation as a formidable debater and public intellectual. Dawkins' contributions to the public understanding of science and his efforts to promote atheism and secularism have earned him numerous awards and honors, including the Royal Society of Literature Award and the Nuremberg Prize for Science in the Public Interest. Dawkins' advocacy for science education and his efforts to combat creationism and intelligent design have made him a leading figure in the fight against scientific illiteracy and anti-science propaganda. Dawkins' influence extends beyond his scientific research to his role as a public intellectual and cultural critic. His books, lectures, and media appearances have sparked widespread debate and reflection on the relationship between science, religion, and society. In conclusion, Richard Dawkins' contributions to evolutionary biology, his advocacy for atheism and secularism, and his efforts to promote scientific literacy have made him one of the most influential figures in modern science and public discourse. His ideas continue to shape debates on religion, ethics, and the nature of reality in the 21st century. William Lane Craig, a philosopher and theologian, is known for his defense of Christian apologetics and his contributions to the philosophy of religion. His debates with atheists and skeptics have garnered widespread attention and acclaim. Craig's work in philosophy of religion has focused on arguments for the existence of God, the nature of morality, and the historical evidence for Christianity. His philosophical rigor and analytical approach have earned him respect from both supporters and critics. Craig is perhaps best known for his formulation of the cosmological argument, which seeks to demonstrate the existence of a transcendent cause of the universe. His defense of the argument in debates and lectures has made it one of the most widely discussed arguments for the existence of God. In addition to the cosmological argument, Craig has defended other philosophical arguments for the existence of God, including the moral argument, the teleological argument, and the ontological argument. His work has contributed to the revival of natural theology in contemporary philosophy. Craig's debates with prominent atheists and skeptics, such as Christopher Hitchens, Sam Harris, and Lawrence Krauss, have attracted large audiences and sparked intense intellectual exchanges. His skillful use of logic and rhetoric has made him a formidable opponent in the arena of public debate. Craig's academic work extends beyond philosophy of religion to include research in metaphysics, philosophy of time, and philosophy of science. His interdisciplinary approach to philosophical inquiry has led to insights into the nature of reality and the limits of human knowledge. Craig's defense of Christian apologetics has made him a leading figure in the Christian intellectual community. His books, lectures, and debates have inspired countless Christians to engage with contemporary philosophical and scientific challenges to their faith. Craig's commitment to rigorous scholarship and his willingness to engage with critics have earned him respect from scholars across religious and philosophical traditions. His ability to articulate complex theological and philosophical ideas in accessible ways has made him a trusted authority for many Christians. Craig's contributions to the philosophy of time, particularly his defense of the A theory of time and his critique of the B theory of time, have sparked debate and discussion among philosophers of physics. His arguments for the reality of temporal becoming have challenged prevailing views in the philosophy of time. Craig's engagement with contemporary science, particularly cosmology and physics, has led to fruitful dialogue between science and religion. His defense of theism as a coherent worldview, compatible with modern science, has influenced debates on the relationship between faith and reason. Craig's advocacy for Christian ethics and his defense of traditional moral values have made him a leading voice in discussions on morality, ethics, and public policy. His critique of secular ethics and his defense of divine command theory have sparked debate and reflection on the foundations of morality. Craig's contributions to Christian apologetics and his efforts to defend the rationality of faith have made him a respected figure in the evangelical community. His work has inspired many Christians to deepen their understanding of their faith and engage with contemporary intellectual challenges. Craig's debates with atheists, agnostics, and skeptics have been characterized by civility, respect, and intellectual rigor. His willingness to engage with opposing viewpoints and his commitment to truth-seeking have earned him admiration from both supporters and critics. In conclusion, William Lane Craig's contributions to philosophy of religion, Christian apologetics, and interdisciplinary scholarship have made him one of the most influential figures in contemporary theology and philosophy. His defense of theism and Christian doctrine continues to shape debates on faith, reason, and the nature of reality. Lawrence Krauss, a theoretical physicist and cosmologist, is known for his contributions to our understanding of the origin and evolution of the universe. His research on the Big Bang, dark matter, and dark energy has shed light on some of the most profound questions in cosmology. Krauss is perhaps best known for his popular science book, A Universe from Nothing, in which he explores the origins of the universe and the nature of nothingness. His provocative thesis that the universe could arise from quantum fluctuations has sparked debate and controversy among scientists and philosophers. Krauss's research on the cosmological constant, a mysterious energy that pervades empty space and drives the accelerated expansion of the universe, has led to new insights into the nature of dark energy and the fate of the cosmos. His work has challenged conventional wisdom and pushed the boundaries of our understanding of the universe. In addition to his scientific research, Krauss is a vocal advocate for science education and public outreach. His lectures, books, and media appearances have inspired countless people to explore the wonders of the cosmos and embrace the power of scientific inquiry. Krauss's advocacy for secularism and skepticism has led him to critique religious beliefs and dogma, particularly those that conflict with scientific evidence. His defense of reason, evidence, and critical thinking has made him a leading figure in the atheist and skeptic communities. Krauss's debates with religious apologists and creationists have been characterized by his sharp wit, formidable intellect, and uncompromising defense of scientific truth. His willingness to challenge religious orthodoxy and defend scientific principles has earned him respect from supporters and critics alike. Krauss's work as a public intellectual and science communicator has made him a popular and influential figure in the scientific community. His efforts to demystify complex scientific concepts and make them accessible to the general public have earned him widespread acclaim. Krauss's criticism of religious belief and his defense of atheism have made him a controversial figure in some circles. His outspoken atheism and skepticism have drawn criticism from religious believers and conservative commentators. Krauss's contributions to the public understanding of science and his advocacy for rationality and critical thinking have earned him numerous awards and honors, including the National Science Board Public Service Award and the Humanist of the Year Award from the American Humanist Association. Krauss's commitment to advancing scientific knowledge and promoting a secular worldview has led him to engage with issues such as climate change, science education, and the role of science in public policy. His advocacy for evidence-based decision-making has influenced debates on these critical issues. Krauss's interdisciplinary approach to science and his willingness to challenge conventional wisdom have led to new insights into the nature of reality and the origins of the universe. His work bridges the gap between physics, cosmology, and philosophy, opening up new avenues for exploration and discovery. Krauss's collaborations with other scientists, philosophers, and intellectuals have enriched our understanding of the universe and the human condition. His willingness to engage with diverse perspectives and disciplines has led to fruitful dialogue and collaboration. In conclusion, Lawrence Krauss's contributions to theoretical physics, cosmology, and science education have made him one of the most influential figures in contemporary science and public discourse. His defense of reason, evidence, and skepticism continues to inspire and challenge us to explore the mysteries of the cosmos and the nature of reality. Albert Einstein, one of the most iconic figures in the history of science, revolutionized our understanding of the universe with his groundbreaking theories of relativity and quantum mechanics. His insights into the nature of space, time, and gravity transformed physics and laid the foundation for modern cosmology. Einstein's theory of relativity, encompassing both special and general relativity, introduced revolutionary concepts such as time dilation, length contraction, and the equivalence of mass and energy, EIMC2. These ideas reshaped our understanding of the fabric of space-time and the behavior of matter and energy on cosmic scales. Einstein's contributions to quantum mechanics, particularly his critique of its probabilistic interpretation and his quest for a unified theory of physics, challenged prevailing views in the scientific community. His insistence on the principle of determinism and his search for hidden variables led to philosophical debates that continue to this day. Einstein's famous thought experiments, such as the twin paradox and the bending of light by gravity, helped illustrate the counterintuitive consequences of relativity and quantum mechanics. His ability to visualize complex physical phenomena in simple thought experiments demonstrated his deep understanding of the underlying principles of physics. Einstein's role in the development of the atomic bomb, through his famous letter to President Roosevelt, urging the study of nuclear fission, remains a subject of controversy and debate. While he initially supported the Allied effort to build the bomb, he later became a vocal advocate for nuclear disarmament and world peace. Einstein's philosophical reflections on the nature of reality, the limits of human knowledge, and the relationship between science and religion have inspired generations of scientists and thinkers. His famous quote, "God does not play dice with the universe," encapsulates his skepticism towards the indeterminacy of quantum mechanics. Einstein's advocacy for social and political causes, such as civil rights, pacifism, and humanitarianism, reflected his deep commitment to justice and equality. His outspoken criticism of fascism and totalitarianism made him a target of persecution by the Nazi regime and led to his emigration to the United States. Einstein's collaboration with other leading physicists, such as Niels Bohr, Max Planck, and Erwin Schrödinger, led to fruitful exchanges and breakthroughs in the development of quantum mechanics and relativity. His willingness to engage with diverse perspectives and challenge established dogma contributed to the vitality of scientific inquiry. Einstein's Nobel Prize in Physics in 1921, awarded for his discovery of the photoelectric effect, helped establish his reputation as a leading physicist and public intellectual. His subsequent work on relativity and quantum mechanics solidified his legacy as one of the greatest minds in the history of science. Einstein's contributions to cosmology, particularly his theory of general relativity and his prediction of gravitational waves, laid the groundwork for modern observational astronomy and cosmological research. His insights into the nature of gravity and the curvature of space-time revolutionized our understanding of the cosmos. Einstein's rejection of the Copenhagen interpretation of quantum mechanics, which posits that particles exist in multiple states until observed, reflected his belief in a deterministic and objective reality. His famous debates with Niels Bohr and other proponents of quantum mechanics highlighted the philosophical implications of quantum theory. Einstein's later years were marked by a quest for a unified theory of physics, often referred to as the theory of everything, that would reconcile the disparate principles of relativity and quantum mechanics. While he was unable to achieve this goal in his lifetime, his pioneering work laid the foundation for future generations of physicists. Einstein's influence extends beyond the realm of physics to popular culture, where he has become a symbol of scientific genius and intellectual curiosity. His iconic image, with unruly hair and piercing eyes, has become synonymous with scientific brilliance and innovation. In conclusion, Albert Einstein's contributions to theoretical physics, cosmology, and philosophy have left an indelible mark on our understanding of the universe and the nature of reality. His insights into the fundamental principles of physics continue to inspire and challenge scientists and thinkers around the world. Simulation theory posits that our reality is akin to a computer-generated simulation, much like a highly advanced video game. According to this hypothesis, the universe, including all matter, energy, and physical laws, is simulated by an advanced civilization with access to technology far beyond our current understanding. Proponents of simulation theory argue that it offers a plausible explanation for various phenomena observed in the universe, such as the fine-tuning of physical constants, the mysterious nature of quantum mechanics, and the apparent absence of evidence for extraterrestrial civilizations. Simulation theory has gained popularity in recent years, fueled in part by advancements in computing technology and the increasing prevalence of virtual reality and augmented reality experiences. Some proponents suggest that future advancements in artificial intelligence and virtual reality could make it possible for humanity to create simulated universes indistinguishable from our own. However, simulation theory remains highly speculative and controversial, with many scientists and philosophers questioning its empirical validity and philosophical implications. Critics argue that the hypothesis lacks empirical evidence and relies heavily on speculation about the capabilities of hypothetical future civilizations. Moreover, simulation theory raises profound philosophical questions about the nature of reality, free will, and the existence of a higher intelligence or creator. If our reality is indeed a simulation, what implications does this have for our understanding of consciousness, morality, and the meaning of life? Despite these challenges, simulation theory continues to captivate the imagination of scientists, philosophers, and science fiction enthusiasts alike. It serves as a thought-provoking thought experiment that challenges our assumptions about the nature of reality and our place within it. In conclusion, simulation theory proposes that our reality is a computer-generated simulation created by an advanced civilization. While the hypothesis offers intriguing explanations for various mysteries of the universe, it remains speculative and controversial, raising profound questions about the nature of reality and our place within it. Panpsychism is a philosophical theory that posits consciousness as a fundamental aspect of reality, existing at all levels of the universe, from subatomic particles to complex organisms. According to Panpsychism, consciousness is not solely confined to sentient beings like humans, but is inherent in all matter. Proponents of Panpsychism argue that it offers a solution to the hard problem of consciousness, which is the challenge of explaining how subjective experiences arise from purely physical processes in the brain. By positing consciousness as a fundamental feature of the universe, Panpsychism suggests that consciousness is not solely dependent on complex neural structures, but is a fundamental property of matter itself. Panpsychism has ancient roots in various philosophical traditions, including ancient Greek philosophy and Eastern religious thought. In recent years, it has gained renewed interest among philosophers and scientists, grappling with the mysteries of consciousness and the mind-body problem. Critics of Panpsychism raise several objections to the theory, including the challenge of explaining how consciousness emerges from non-conscious matter, and the problem of accounting for the rich diversity of subjective experiences observed in sentient beings. Despite these challenges, Panpsychism continues to inspire philosophical inquiry and scientific research into the nature of consciousness and its role in the universe. Some researchers suggest that future advancements in neuroscience, quantum physics, and artificial intelligence could provide insights into the validity of Panpsychism as a scientific theory. Panpsychism also raises profound philosophical questions about the nature of consciousness, the relationship between mind and matter, and the implications for our understanding of the universe and our place within it. In conclusion, Panpsychism proposes that consciousness is a fundamental aspect of reality, existing at all levels of the universe. While the theory offers intriguing solutions to the mysteries of consciousness, it remains speculative and raises profound philosophical questions about the nature of mind, matter, and the universe. The eternal universe hypothesis proposes that the universe has always existed and will continue to exist indefinitely into the future. According to this hypothesis, there was no singular moment of creation or beginning of time. Instead, the universe has undergone an infinite series of cycles of expansion and contraction. Proponents of the eternal universe hypothesis argue that it provides an alternative to the Big Bang theory and the notion of a finite universe with a beginning and an end. They suggest that the universe may operate according to cyclical patterns, with each cycle of expansion and contraction giving rise to new universes. The idea of an eternal universe has roots in various religious and philosophical traditions, including certain interpretations of Hindu cosmology and ancient Greek philosophy. In modern times, the hypothesis has been revisited in the context of cosmology and theoretical physics, particularly in response to questions about the ultimate fate of the universe. Critics of the eternal universe hypothesis raise several objections, including the lack of empirical evidence to support the idea of an eternal universe and the challenge of explaining phenomena such as the cosmic microwave background radiation, which is considered a remnant of the Big Bang. Despite these challenges, the eternal universe hypothesis continues to inspire speculation and debate among scientists and philosophers interested in the origins and fate of the universe. Some researchers suggest that future advancements in cosmology and theoretical physics could shed light on the validity of this hypothesis. The idea of an eternal universe raises profound philosophical questions about the nature of time, causality, and the concept of infinity. It challenges our intuitions about the origins and boundaries of the universe and invites us to reconsider our understanding of reality. In conclusion, the eternal universe hypothesis proposes that the universe has always existed and will continue to exist indefinitely into the future. While the hypothesis offers an alternative to the Big Bang theory, it remains speculative and raises profound questions about the nature of time, causality, and the concept of infinity. Cyclic models of the universe propose that the universe undergoes an infinite series of cycles, each consisting of a period of expansion followed by a contraction. According to these models, the universe does not have a singular beginning or end, but instead undergoes periodic cycles of cosmic evolution. Proponents of cyclic models suggest that they offer an alternative to the conventional Big Bang cosmology, which posits a singular moment of creation. Instead of a single explosive event, cyclic models envision a universe that goes through repeated cycles of expansion and contraction, with each cycle giving rise to a new iteration of the universe. Cyclic models draw upon concepts from theoretical physics, including string theory and brain cosmology, to propose mechanisms for the cyclic nature of the universe. These models often involve the idea of multidimensional space-time and the existence of additional spatial dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. One prominent example of a cyclic model is the ekpyrotic universe theory, which suggests that our universe is the result of a collision between 2 higher dimensional membranes, brains, in a higher dimensional space. According to this theory, the collision initiates a period of expansion, followed by a contraction, and then another collision, leading to a new cycle. Cyclic models also offer potential explanations for phenomena such as the large-scale structure of the universe, the distribution of galaxies, and the cosmic microwave background radiation. By positing a cyclic nature for the universe, these models seek to address some of the unanswered questions and mysteries of cosmology. Critics of cyclic models raise objections regarding the feasibility of the proposed mechanisms for generating cycles, as well as the lack of empirical evidence to support the idea of a cyclic universe. Additionally, some argue that cyclic models may face challenges in accounting for observations, such as the increasing rate of cosmic expansion. Despite these criticisms, cyclic models continue to be explored and refined by researchers in cosmology and theoretical physics. Advances in observational astronomy, particle physics, and gravitational wave astronomy may provide insights into the validity of cyclic models in the future. The concept of a cyclic universe raises profound questions about the nature of time, causality, and the ultimate fate of the cosmos. It challenges our understanding of cosmic evolution and invites us to reconsider the possibility of a universe without a singular beginning or end. In conclusion, cyclic models of the universe propose that the cosmos undergoes an infinite series of cycles, each consisting of expansion and contraction. While these models offer intriguing alternatives to conventional cosmology, they remain speculative and face challenges in terms of empirical support and theoretical feasibility. Other speculative theories about the origins and nature of the universe exist beyond the ones previously discussed. Some of these theories draw inspiration from concepts in theoretical physics, while others originate from philosophical or metaphysical speculation. One such theory is the idea of a simulated universe, which posits that our reality is a computer-generated simulation created by advanced beings or civilizations. Proponents of this theory suggest that the universe exhibits properties consistent with computer simulations, and that certain phenomena, such as quantum indeterminacy, could be explained by the computational nature of reality. Another speculative theory is the concept of a holographic universe, which proposes that the three-dimensional reality we perceive is a projection from a two-dimensional surface, analogous to a hologram. According to this theory, the information encoding our universe's properties is stored on the boundary of space-time, known as the holographic principle. Some theories explore the possibility of parallel universes or a multiverse, where multiple universes with different physical laws and properties coexist. These theories often arise from interpretations of quantum mechanics and string theory, suggesting that our universe may be just one of many within a larger cosmic landscape. Certain philosophical and metaphysical theories contemplate the idea of a cosmic consciousness or universal mind, which underlies and pervades all of reality. According to these theories, consciousness is not merely an emergent property of the brain, but is fundamental to the fabric of the universe itself. Other speculative theories propose radical revisions to our understanding of time, space, and causality, challenging fundamental assumptions about the nature of reality. These theories often push the boundaries of scientific inquiry and invite interdisciplinary exploration across philosophy, physics, and cosmology. While these speculative theories offer intriguing possibilities for understanding the universe, they remain speculative and often lack empirical evidence or rigorous theoretical support. Nevertheless, they inspire curiosity and creativity in exploring the mysteries of existence and the cosmos. In the absence of definitive answers, speculative theories serve as thought experiments and intellectual exercises, stimulating debate and inquiry into the fundamental nature of reality. They remind us of the limitations of our current understanding and the boundless possibilities for exploration and discovery. Ultimately, the quest to understand the origins and nature of the universe is an ongoing journey marked by curiosity, inquiry, and imagination. Speculative theories play a role in this journey, pushing the boundaries of knowledge and challenging conventional wisdom. In conclusion, various speculative theories exist regarding the origins and nature of the universe, ranging from simulated realities to holographic projections and parallel universes. While these theories offer intriguing possibilities, they often lack empirical evidence and rigorous theoretical support. Nonetheless, they stimulate curiosity and imagination, fueling the ongoing quest to unravel the mysteries of the cosmos. Throughout this video, we've delved deep into the question of whether we need God to explain how the universe started from nothing. We started by providing an overview of the topic, highlighting its importance and exploring its historical context. We then examined the philosophical and scientific perspectives, considering various arguments and theories put forth by theologians, philosophers, and scientists. From creation myths to modern cosmological models, we explored a wide range of ideas and concepts, uncovering both common misconceptions and critical insights. We discussed the influence of influential thinkers such as Stephen Hawking, Richard Dawkins, and William Lane Craig, each offering unique perspectives on the topic. We also explored the impact of upbringing, personal experiences, and cognitive biases on individuals' beliefs about the origins of the universe. Furthermore, we examined the role of speculative theories in expanding our understanding of reality, from simulated universes to holographic projections and parallel worlds. As we conclude this journey, I encourage you to reflect on the diverse perspectives and ideas presented in this video. Whether you found yourself aligned with philosophical arguments, scientific theories, or speculative hypotheses, I hope this exploration has sparked curiosity and stimulated your thinking about the nature of existence. If you enjoyed this video and found it insightful, please consider liking and subscribing to our channel. By subscribing, you'll stay updated on future videos exploring fascinating topics in science, philosophy, and beyond. And don't forget to check out the rest of the videos on our channel, where we continue to delve into the mysteries of the universe and uncover the wonders of human knowledge and understanding. Thank you for joining us on this journey of exploration, and we look forward to continuing the conversation with you.